The Unity first version was launched in 2005 with only the Mac OS support, and they launched the second version with 50 plus new features. Until now, the Unity has changed a lot. The new versions are coming and extending so rapidly that not every developer gets enough time to get updated with the latest tools and techniques. And that's why I welcome you in this course. This guide helps Unity creators save time and boost productivity with over 100 plus tips on how to work faster with programmers and artist toolsets individually or on a team. These tips work here with new and existing features in Unity 2020 LTS and above. Whether you are a new or experienced Unity developer, reference this guide to speed up workflows in every stage of your game development. Unity should be a joy to use. When millions of users repeat a task multiple times per day, every second or mouse click adds up. I want creators to waste less time and be more productive. This course has 4 sections: editor, artist, developer, and team workflows. And each section covered multiple topics. Like in the editor workflows, we are covering package manager, shortcut manager, focus inspector, presets, scene visibility, scene picking, searching, inspector debug mode, quick search, and many more editor workflow tips. And in the artist workflow, we have 2D art and workflow tips, Sprite Atlas, 2D workflow tips, prefab workflows, TextMesh Pro, snapping, animation workflow, customized gizmo and icons, progressive Lightmapper, light props. And in the developer workflow, we have attributes, custom windows and inspectors, custom menus, enter play mode settings, script templates, addressables, preprocessor directives, scriptable objects, managing assemblies, IDE support, debugging, additional debug tips, Visual Studio shortcuts, device simulator, console log entry, and custom compiler status. And in the team workflow, we have source control and Unity Accelerator. These are the major techniques, but in this course, you will be learning 100 plus techniques that will speed up your workflow and save you a ton of time. That was the short introduction of the course. It's a self-paced course spread out 45 plus lectures. I will be updating this course and adding the latest techniques. And you are getting this course for the lifetime. I will be demonstrating and explaining these techniques step by step in a simple way. This course is not just about videos, and in parallel you will be following me. As you will be completing the sections, you are going to be tested. And for testing, at the end of each section, you are going to have quizzes and assignments. If you are stuck on the way, you have my instant support. I will be standing by to help you and to resolve any query you have. Hundreds of people are joining this course from the globe. My name is Tanveer Sabir and I'm your instructor for this journey. I am software architect and XR developer and have the game industry experience of more than 12 years. Unity 2020 LTS includes multiple improvements that speed up editor workflows, such as keyboard shortcuts to launch frequently used features, handy user interface to reduce the repetitive task, improvement to the debugging workflow, and much more. Collectively, these improvements can save you hours of work over days and weeks. Your quality of life with Unity improves because you iterate faster and develop more efficiently. Try out these tips and shortcuts to go faster in Unity. Let's get started. We will be looking into Package Manager as it has several design updates in Unity 2020 LTS and above. We will be looking into new interface, icons, improved layout, and better distinctions between information for currently installed packages and for available updates. To open a Package Manager, go to Windows and click on Package Manager. We will explore all the functionality one by one. And here you can see overall interface of Package Manager. In this panel, we can see all the installed packages. By clicking on any package, we can see more information of that package on this right side panel, and the green check icon represents the packages updated to the latest version. This black and white up arrow shows the new version of this particular package is available to update. To update any package, we simply select the package and click on update button to update the package to the latest version. It will take few seconds to download and compile the latest package. We have updated the test framework to the latest version, but if we want to, we can also update any package to the specific version. We can click on this triangle icon to see the current and the latest available version, and click here to see all other versions, and from the list we can switch to any version. In case you are facing an issue with the latest version, you can always roll back to your previous version. For a Visual Studio editor, I'm selecting the latest version and updating it, as these are all installed packages in the project. And now let's see how we can install the other packages provided by Unity. We can access the other packages by clicking here and select Unity registry, and it will grab all the packages provided by Unity. As we can see in this list, we have different kind of packages. We have 2D packages, we have AR related packages, AR Foundation, AR Kit, AR Core, and several different other packages. And the packages that are installed and we are using, they have a green check mark. To install a new package, just simply select the package and click on this install button. It will download and compile the package. It will take a while depending on the package size, and it will show the green check mark after installing the package. As you know, for the package detail, we have information in this panel. For more detail, we can click on more to expand the description of the package. To read more about the documentation of the package, we can click on view documentation. It will open the Unity official documentation page, and here you can read more about the package in detail. Let's close this page and try on the other package. Opening the documentation for Unity Ads. From here we can also read the documentation of specific version of the package. By clicking on view license, we can see the license information of the package. So this was all about installing the Unity provided packages. As we have a long list of packages, so Unity has provided an option to sort the packages. Click here to open the 4 available sorting options. We can sort them by name or by publish date in ascending or descending order. Let's try sorting by publish date in ascending order, and this is how it looks. Apart from these verified assets, Unity also provide preview packages. Basically, these packages are under development and in testing phases. By default, Unity doesn't show these packages, but we can enable them. Click on this setting icon and select the advanced project setting. At the bottom, check enable preview packages. We are enabling it for the first time and it's giving us alert message. Preview packages are in early stage of development and not ready for production. We recommend using these only for testing purpose and give us direct feedback. Click on I understand and close the project setting window. So now in the Unity registry option, we can also see the preview packages. Preview packages are not recommended to use in the production project. Currently in preview packages, we have 2D IK, 2D Tile Map, Device Simulator, Game Foundation, Havoc Physics for Unity, Jobs, Memory Profile, Mock HMDXR plugin, Talent Tools, UI Builder, Unity Netcode, Unity Reflect, XR Interaction Toolkit. Now let's enable the package dependency option. Click this setting icon and select advanced project setting, and at the bottom check show dependencies and close the project setting window. Now we can see the dependency option at the bottom of information panel. Here we can see the dependent package information. Like here in USD package, we have a list of in-use packages, and these are the dependencies for 2D tile map package. For the testing purpose, I'm installing a UI builder, that is a preview package. And few packages also provide the option to download the samples. As UI Builder providing a 5 samples, click on import to download the samples into your project. When we use a preview package, Unity Editor also indicate that your project is using a preview package. If you want to know which Unity preview package is installed into your project, you can click on preview package indicator and select show preview package, and it will take you to the used preview package. And if you want to reset your all packages to the default version, click on setting icon and select reset packages to the default. It will give you the warning. Click yes if you want to reset. For the testing purpose and to show you, I will be resetting it. And now we are back to the default packages. Now let's move to the Unity Asset Store packages. Click on packages and select my assets to access all your Unity Asset Store packages. Here we can see the list of all the assets paid or free that I have added into my Unity account using Unity Asset Store. You can click on asset to know more about it. We can download the assets by clicking here the download button. A download progress will start. After downloading the package, we will see an import button. This icon means this package is not downloaded yet, and this icon means it's downloaded and we can import into our project. If any Asset Store package have a dependent package in Package Manager, it will show us a warning like this. This package is used to integrate Unity ads more easily, and it's using advertisement package from the Package Manager. By clicking here view in the Asset Store, we can see the package in the Asset Store, and from the Asset Store we can see more detail about the asset. Let's close this and go back to Unity. And by clicking here, we can see the asset publisher website. Let's get back to Unity. If you bought a package and after a while it's not available on Asset Store, Unity will add the depreciation tag against that package, and it won't be available for the new user, but you can import and use the package. And sometimes the publisher have the asset at their own website but not at the Unity Asset Store. Like here, you can download the Facebook Unity SDK from the Facebook website. In My Asset tab, we have an extra sorting option with the purchase date. By clicking here, we can refresh the package list if the packages are not properly loaded. In My Asset tab, we also have an option for filter. In filter, we have a status and categories. Let's try the different variation to filter the packages. Let's try the 2D packages, and from here we can clear all the filters. In the packages list, in the last option is built-in packages. Here we have all the built-in packages. And the most important and key feature of Package Manager is the search bar. We can search the packages. Here I'm searching an AR and it's giving me an AR related packages. Using this plus sign, we have three options to import the packages into our project. And the first option is add package from the disk. Using this option, you need to open your custom local package and search for the package.json and click open. It will import the package and it will also install all the dependencies of the package. And the second option is add the package from the tarball. To import the package using this option, you need to download your package with the extension .tgz. And for the third option, let's copy the repository URL. Select the third option and place the URL and click add. It will start downloading and installing the package. And that's it for the package manager, and I see you in the next. The Shortcuts Manager lets you view and manage keyboard shortcuts in Unity. It's an interactive visual interface to help you manage editor hotkeys. A shortcut is a key that is bound to a Unity command, and command is an action that is executed in Unity editor. For example, the F key is bound to a command that is used to focus on any game object in the scene view. Now I'm using a shortcut key command N to create a new scene. Click create to have a new scene in the project. Now I will be using a shortcut key command S to save this scene. Here we can enter the name of the scene. Select the location of the new scene and hit save. Let's create a new cube to have some experiments using shortcuts in editor. Let's try how we can access these tools using shortcuts. You can access the hand tool by pressing Q. You can activate the move tool by using W shortcut key, and using it we can move around the game object, and using handles we can change the value of X, Y and Z. And the next is rotate, and we can access it by pressing E. Using the rotate tool we can rotate the object in any direction. Next is scale tool. We can access the scale tool using R shortcut key. Using the scale tool we can change the shape of this cube. Using the shortcut key T, we can access the rect tool. The rect tool can be used to move, resize, rotate UI elements. A shortcut key Y is used to access the next tool. This tool is a good addition in the Unity editor. It's a combination of rotate, resize and move tool. Now most of the time I use this tool instead of selecting them individually. To duplicate any game object, we use command D. Let's move out the duplicate of this copy so you can see it. The duplicated cube name is cube 1. Here duplicated one more cube from the cube 1. And each copy of this cube have their own set of components. If we want to focus on any game object, we can use the F key. But to focus, our arrow should be in the scene view. To focus on any game object, we can also select the game object from the hierarchy view. It's a very useful and time-saving command, especially if you have hundreds of game objects in your scene. You can select multiple game objects, and you can focus on group of game objects using this same command. Next, we are going to try align with view, setting up the scene to view the effect. Select the main camera and finalize the view in the scene. We can apply the view using the shortcut key Shift Command F. Now you can see we have the same angle in scene and game window. As you know, we can access all these commands through menus. You can always learn the main commands from the menus. They are written in mostly front of the option. Making the habit of using shortcut keys, it's very easy to use, and of course they are time saving. The other useful commands for the panels, they are start from command 1 to command 8. Using these, we select and focus the panels. Command 1 to focus on scene panel, command 2 for game, and command 3 for inspector, and 4 is for hierarchy view, command 5 for project panel, and command 6 is for animation panel. 7 is for profiler, and command 8 is for audio mixer. Now let's come to the main part of this video, the shortcut manager. Open the Unity menu and click on shortcuts to open the shortcuts manager. Profile drop-down menu allows you to manage and switch between different shortcut profiles. The key map shows you which keys are assigned to commands and the commands they are assigned to. You can also use the key map to manage shortcuts. Category list. Commands are sorted into categories. which appears in category list. When you select a category, its command appear in the command list on the right side. This area is for commands and shortcut list. List all the commands in the selected category and their assigned shortcuts. By selecting the category, we can filter the commands that are relevant. As you can see, we have several different categories: camera, curve editor, grid, hierarchy view, the particle system, profiling, property editor, scene picking, scene view, scene visibility, snap, stage, terrain, timeline, tools, windows. And we can also search for a specific command by typing here. Like I'm typing a copy, and I will be selecting the all unity commands to search the copy command. As you can see, we have a copy relevant commands that we have searched. Now let's try the other string duplicate. So here we have a duplicate command. We can manage the multiple profiles for the shortcut keys. To create a new profile, click here and select create new profile and enter the name of the profile. I'm typing here Tanveer and click on create. So now we are in the Tanveer profile. The changes we will made in this profile will not affect the default profile. This can be very useful where you want to manage different profiles for the different projects. As you know, we can also alter the existing commands. Let's search for the new scene command and we will be changing it. We are going to change it to command G. Now to create a new scene, instead of command N, we will be using a command G. We can also reset and remove the shortcut key. In the key map, pink keys are assigned to global commands and the blue keys are assigned to contextual commands. White keys not assigned to any commands. Gray keys are special keys that cannot be assigned to commands. For example, modified keys such as shift and control or command, or utilities such as return and escape. Let's take a folder and script creation example to see how a shortcut key manager can be very useful. Take a look at the process of creating a new folder. We go to assets, create and folder and enter the name of the folder. Now let's create a new script inside script folder. We are going to asset, create and C# script. In your project, if you are going to create many folders and scripts, we can make this process even faster. Using Shortcut Manager, we will create a shortcut key for creating a new folder and to create a new script. I'm writing a create in a search bar. Now it's showing all the create related commands. Let's search for the create folder. Double click on it and enter the shortcut key you want to use it for creating a new folder. Also enter a shortcut key to create a C# script. For the script, I'm using a command B, and to create a folder, I'm using a command U. Now press command U to create a new folder. Okay, nice, it's working. Let's enter the folder name. Click on the folder and this time let's try command B. Yes, now we have a new script using command B. Enter the script name. Here you take a look at the few commands that are related to tools. And these are for game objects. And these are Windows related command. These are edit commands. And these are the animation commands. Now we have seen it's very fast and easy using shortcuts. It sort of automate the process and saving your time using mouse searching and clicking in the menus. And regarding the shortcut profile, we can also export and import the profile to use in another project. I hope this video helps you. If you have any question, you can always ask. And thank you for watching. I see you in the next. Unity 2020.1 introduced the Focus Inspector window, which allows you to inspect the properties for a specific game object, component, or asset. It always displays the properties of the item you open it for, even if you select something else in the scene. Let's take a look how we were doing this before now. In this panel, we have different game objects and we can click on them to see their properties in the inspector panel. Inspector panel also shows all the components attached to that particular object. Let's say I want to see the properties of a specific game object all the time, even I click the other game object. So this is the old way of doing it. Open a new inspector panel. So now we have two inspector panels. I'm going to dock one at the bottom. Let's click on a player cube. You see the properties are changing in the both panels. To hold the properties of one panel, what we can do is click on this lock button. Click on any game object. Now you will see the properties in the bottom panel will not change. We use this technique when we need to inspect something in the game object, and it's a useful way of looking at the properties in the real time. Using this, we are looking at two game object properties, but we can add more windows to inspect other game objects as well. And of course, you can change the properties of game object. In the real time, you can change the transform component and other components to see the different effects on the player. Here I am making a changes in the Z direction while I am looking at the properties of the main camera. Exit the play mode and close the inspector panel, and now we will take a look how the focus inspector works. Right click on any game object. I'm taking player cube. At the very bottom you will see the properties. Click on it. This reveals a floating inspector window that you can reposition, dock, or resize like any other window. And we can also open a property window for a specific component as well. Dock it here and let's see what's the visible difference between these two. Both look similar, but with the difference of this lock icon, we don't have the lock icon on focus inspector panel, as it always be appear. Now click on play button to see how this actually works. As we can see, we are clicking on different game objects, but the focus inspector panel that we open for the player cube is always be appear. It make it really easy to debug and inspect different values of a game object. Exit the play mode. Let's try more focus inspector windows. This time I want to inspect the properties of main camera. The process is the same. At the very bottom, select properties, and here we have the property panel for main camera. And I will dock this window under the player cube. So now we have three panels. One is inspector window, player cube window, and main camera window. So now we have two focus inspectors. One is for player cube and one is for main camera. Start the play mode and see how this goes. As you can see, these windows are staying at their positions and we can inspect multiple game objects at the same time in real time, and of course we can change their values. Changing the Y position of the main camera. Now altering the Z value and altering the X value. Suppose this is my hyper casual game and I want to try a new camera angle in the game, so I made changes in the main camera. And now suppose I want to experiment with different light settings for my game. Right click on light component and select properties of directional light game object. As I told you earlier, we can also have a focus inspector panel for a specific component as well. If any game object have 5 different components, we can open 5 different focus inspector windows for them to inspect them. Enter the play mode and we will experiment with different light settings. First we will be experimenting with light color. And now let's try different lightings. If you are prototyping your game and you need to experiment with different components to match the look and feel of your final experience, so it's a very handy way of doing it. It's really boost up overall process and save you a lot of time. And if you know which component you are going to inspect on a game object, I would recommend you only open a property of that component, as it will take less space on your screen. Let's exit the play mode. If you are done with any window or you don't need it anymore, click on these 3 dots and close tab to save the space or to open other window. You can quickly reset to default layout if you are done with all the focus inspector panels. This way you don't have to manually close all the windows. The alternate way of opening focus inspector window by menus is selecting the game object and going to assets and select properties. In Unity editor, if we have open multiple windows and we want to see all the open windows that we have open in Unity editor, we can always go to Windows, select Panels, and here is the list of all the open windows, including the floating windows. We can select any window to open it or to focus on that. It is recommended to open one window at a time and dock it in the Unity editor so you don't lose the focus on other window. So here I'm quickly reopening and docking all the windows. Another useful tip is if we hover the cursor over the window name, it will show you the complete path of that component. And at the last, if it's a script, then name of the script. First, we have the scene name to which this component is belonged to. Then we have a game object name to which this component is attached. If you are working on a big project and you have hundreds of game objects in the hierarchy view, and you also have opened a multiple focus inspector windows, right click on the window name and select ping. It will highlight the game object in the hierarchy view. And you quickly want to know this focus inspector window belongs to which game object in the scene. Let's try this one more time with the plain track. Now let's ping the main camera. In this video, we have covered focus inspector windows even with the small techniques. But when we use all these in a combination, it really boosts the work process and save you a ton of time and overall enhance your productivity. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. Presets feature of Unity allows you to customize the default state of anything in your inspector. Creating a preset lets you copy the settings of component or assets, save it as an asset, then apply the same settings to another item later. Use presets to enforce standards or to apply reasonable defaults to new assets. This ensures consistent standards across your team, so commonly overlooked settings don't impact your project performance. Creating a new cube to demonstrate presets. First, let's take a look how we do it before presets. Let's say we want to place our newly created cube at the position of player cube. Player cube is our that yellow cube. One way of doing it, manually repositioning this cube using these handles and hoping for its placed at the correct position. Let's reset the white cube at its original position. The second way is click on yellow cube and copy the transform component or only the positions and paste it on the white cube. Now we have transform component copied. Click on white cube and click on these three dots and click on paste component values. As we can see, the transform component is changed and the white cube is exactly positioned at the yellow position. Still, this method have a drawback. When we will be copying a new value, it will be replaced by the last one. We cannot save them to later reutilize it. So that gap is filled by the presets. On every component, you see this icon. It's a preset button to access all the presets. At the moment, we don't have any preset. We will create a preset folder to create all the presets at one place, naming it as presets. The first prefab I want to create will be the transform component of player cube. Select the player cube and click on the preset button. At the bottom left corner, click on save current to and select your desired folder to save the preset. And now click on save. As we have saved it in the preset folder, open the folder. And here we have a preset of transform component that we have created from the player cube. By clicking on it, you can see basically it's holding the values of the transform component. Click on the preset button on the transform component of white cube and select the transform preset. As we are selecting the preset, it's applying the preset to the white cube and repositioning the white cube by applying the preset values. And that's the simplest way of using presets. Now let's see what more we can do with the presets. Next, I will be customizing this cube by changing its color and the collider. Changing its color to red and randomly customizing the size of the collider. Next, we will be creating two presets, one for the renderer and other one for the box collider. Click on the preset button on the mesh renderer and click on the save preset and select the folder. Our folder is preset and click on save. Next, we will be saving a preset for the box collider. The process is the same, but it's recommended to enter a relevant name. Like here, we have a box collider. Let's make it enemy box collider, so you can know for which purpose this preset is going to be used. We are creating a new cube to apply the presets. Let's say it's an enemy cube and we will be applying the presets that we have created from the red cube. Click on the newly created white cube and select the mesh render and click on the preset button to select the preset. The color is changed to red, and now let's apply the box collider. On the box collider, click on the preset button and select the enemy box collider. And here we have the customized box collider. Although we have 3 presets, but when we try to select from the mesh render or from the box collider, it shows only the one preset because it filtered the presets and show only the relevant presets. When we are selecting a preset for the collider, it will shows only the list of collider presets. The values of presets are not fixed. We can alter them. Click on any preset and from the inspector you can change their values. Changing the value of presets will not affect the previous game objects. In our case, we have applied the presets to these red cubes. They will retain their characteristics. Let's create a new cube to apply the altered box collider preset. Open the box collider presets and select the enemy box collider preset. So you see white cube have a altered value 1.1 and 1.82. And the old red cubes are retaining the old values. So you see the presets are very flexible. Now I will be showing you the other way of applying presets to the game objects. Created a new cube. This time grab the box collider preset and drop it over the box collider component. So we have applied the preset directly to the game object component. Drag and drop the preset to the empty space if you want to add the box collider instead of replacing the values of the existing box collider. Now let's take a look at the other way of using preset. Deleting this cube, drag the preset and drop it over the hierarchy view. It will create a new game object with that component. It was a box collider preset, so it's created a new empty game object with the box collider component and of course the transform component. Let's try something more with the presets. Now I'm shuffling the randomly value of this cube. Now let's say one more transform component. Click Save Run To. In the preset folder, let's click on Save, and this will be our enemy transform 2. To apply this preset, I will be creating a new 3D cube. But before applying, I will be altering the preset. In the preset, I will be excluding the position and scale. So now this preset will only have the rotation change. Select the new cube and apply the enemy transform 2 preset. As we can see, it's only applying the rotation from the preset. Although the old cube have a different shape, but the new cube only taking the rotation values. Here we have a texture. We can also save the texture properties as a preset. So when we will be adding a new texture, we don't need to apply all the settings again and again. We just simply apply the preset to the texture. Now saving a texture preset. We can even create a preset for the project graphic settings. And then we can export the presets and import in the other project to apply the graphic settings. Open the project setting and click on graphics and click on preset button and click Save Run To and select the preset folder and click on Save. And the same way we can save the physics setting of the project. And it's really time saving when we are starting a new project, importing the graphics and physics settings and get started to your work. And of course, we can also save the player settings, and that saves a lot of time as well. We can also create a preset for tags and layers as well. Let's create a preset and save it. As you can see, now we have different kind of presets. We can click on them to view their values, and even we can change the values if we want to. And the beauty of presets is we can share them with our team members. So every time we don't need to apply all the core settings. To export presets, select the folder and click on Export Package. Unchecking Include Dependencies, selecting the folder. Enter the name of the package and click Save. So here we have our preset package we can import into any other project and utilize them. In this video, we have seen the different ways of creating and utilizing the presets. If you are working independently or with the team, presets are very useful, and presets can really reduce the setup time of your next project. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. As your scene grows larger, you can temporarily hide specific objects so that you can select and edit your game objects with more ease. Instead of deactivating the game objects, toggle the scene visibility controls. This allows you to hide and show objects in the scene view without changing their in-game visibility. This is a big project with a massive game level design. I want to make few changes and inspect this level. For that, I will be changing the visibility of the game object. Select the game object you want to disable the scene visibility and click on this eye icon to disable the scene visibility of that particular game object. These icons shows only when you hover over the game objects. If the game object have child, by default it will also disable the scene visibility of all the childs as well. We can enable any child by clicking on the eye icon. And now the parent icon changed to this. That means few childs are enabled and few are disabled. Using the command H, we can toggle it on and off. If you select any game object and press the command Shift H, it will keep that game object enabled and will disable all the other game objects. And pressing it again, it will enable all the game objects back. And remember that you can always use the Shift plus spacebar shortcut to maximize the viewport and hide the rest of the editor as well. As you can see, we have disabled few game objects in the scene view. These game objects are basically our walls in the level design. Let's enter the play mode, and here I want to show you that the scene visibility option is only affects in the scene view. As you can see, these walls are visible in the game mode, but they are disabled in the scene view, as we have disabled their scene visibility in the scene view. So that means the scene visibility option only affects in the scene view to make your level design easier and to inspect something in the scene view more easily. And if you have multiple game objects scene visibility disabled and you have created your final build using that scene, all the game objects will be enabled and visible in your final build. So that doesn't affect your final build. And here we can see the total number of disabled scene visibility game objects. And by clicking on this button, we can toggle them on and off. That's it for the scene visibility. The scene visibility is an incredible option by Unity. It really helps, especially the level designers. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. Unity has a variety of attributes that can be placed above a class, property, or a function to indicate special behavior. And C# contains attributes names within the square brackets. In this video, I will be showing you some common attributes you can add to your scripts. The first one is serialized field. This forces the Unity to serialize a private field and make it visible in the inspector. In this example, I have a player class and a private variable myObject with the type of game object. As I switch back to Unity, we cannot see the private variables in the inspector. For any reason, if you want to see the myObject in the inspector panel, instead of making it public, we can serialize this field. And the syntax is very simple. On top of the variable, type serialized field inside the square brackets. Note that you may experience a 0649 warning when you're applying a serialized field to a private variable. To prevent this, simply initialize the variable upon declaration. For convenience, you can use a keyword default. Now switch back to Unity to view the impact. And give it a moment to recompile it. And now the inspector window will refresh itself. Now we can see the myObject in the inspector. Next, we have a range attribute. This attribute takes a float or int variable restricted to a specific range. These fields appear as a slider in the inspector. To show you this, I have written two variables. Integer range is an integer type and a float range is a float type. Switch to Unity to view how they display in the inspector panel. So we have a number value in both fields, and we can select the field and type the number we want. And there is no restriction in the range as well. To specify a fixed range and to add a slider, we will be using a range attribute. Go back to Visual Studio. On top of the variable you want to convert to a slider, in the square brackets type range, and in the parentheses type the range. I'm typing 2, 10. Actually make it 1 to 10, and that will create a slider in the inspector that will be ranged from 1 to 10 for the integers. Switching back to Unity to view the changes. And there we go, we have a nice slider with a range of 1 to 10. We can make it all the way go to up to 10 or all the way down to 1. And you can manage the user easily within the defined range. And manually, if you try to add a bigger value, it will make it back to the max, as it's an integer slider, so it's moving in an integer like 1, 2, 3. Jump back to Visual Studio and convert the float range, and it's a float variable. Following the same syntax, just value will be in the float. Now add the parentheses and give it the starting point. I'm giving 0.2f, comma, and 0.9f. So that's my range for the float. That's it. Switching back to Unity, and here we have a slider for the float range, and it will increase or decrease the value in the float, and the minimum value is 0.2 and the maximum 0.9. For the end user, it's really easy to use, and we can also keep it in the defined range. Next attribute, we have hide in inspector. This make a variable not appear in the inspector but to be serialized. For the demonstration purpose, I have declared a points variable. We have public int points is equal to 25. Switching back to Unity, so it's a public variable we can view in the inspector. In case if you want to hide the public variable, we can use hide in inspector attribute. Go back to your script, and on top of this variable in the square brackets type hide in inspector. IntelliSense is a great way of writing a code quickly. I just typed the HI and it's already predicting that do you want to type hide in inspector. To quickly type it, you can select it or press enter. Switch back to Unity, and you see now the public variable is not displaying in the inspector. The next attribute we have is required component. This automatically adds required component as dependencies to avoid setup errors. Please note, these attributes only check the moment that the component is added to a game object. To demonstrate this, I am adding a rigid body variable and a start method to get the rigid body component at the start. We will be holding a rigid body component in rigid body, and using get component, we are getting the component of rigid body. Switching back to Unity, so we have rigid body as public, and now enter the play mode. The project is started, but we didn't get anything in the rigid body. One way is we can manually add the rigid body and assign it, or what we can do is we can use a required component. This time on top of the class in the square bracket type required component. In the parenthesis type of, and again parenthesis, and give it a rigid body. So it's kind of automating the process. So we are telling this is a required component, please add it yourself dynamically. And of course, in many situations, we need to add different components at runtime. Go back to Unity and start the play mode. As we start the project, Unity added a rigid body component to this game object. And from the start method, we get the rigid body component and assign to this variable, rigid body variable. And we can also make this variable a private variable and start the project, and it will work as same before. Just with the difference, it won't show the rigid body variable as it's private now, making it back to public. Next attribute, we have a tooltip. This shows a tooltip when the user hover a mouse over a field in the inspector. And the syntax is very simple. In the square brackets, just type tooltip, and in the parentheses pass a string as a tip. I'm writing player power value between 1 and 10. Going back to Unity, and now hovering the mouse over integer range, as we have typed it over top of the integer range, and we have a nice slider, and it's also giving a tip what is all about. And we are only getting the tip on the integer range. We can add tips on all the variables as well. And the next attribute we have space. This adds a small space between your fields without any additional text to create a visual separation between your fields. Type space and give it the space value. I'm giving it 10. That's mean the 10 pixel space. Saving the script and switch back to Unity. Now we have a space of 10 pixel below the my object and above the integer range. So it looks nice now. Let's try the 20 value and see the impact. Keep an eye on the empty space. Yeah, now it's extended a bit more. And that's how you can also differentiate the different type of functionality. You can make a group of functionality. Now let's try adding a space above the points variable. The point variable is actually hidden, so it will be giving a space above the rigid body variable. Actually, let's move it above the rigid body. It looks clean. And make the both spaces around 15. Go back to Unity and let it refresh. Using space, we have kind of separated the sliders from the other variables. And next attribute we have header. This adds some bold text and spacing to help organize your variable in the inspector. Only add this to the first field that you want to belong to the group. In the square bracket type header and in the parentheses give a string of header. We are adding it above the integer range, so these are our power settings. Switching back to Unity and after the refresh we will have a header above the integer range. So here we have our power settings now. And it's kind of telling the end user that these sliders are the power settings. Open the Visual Studio and actually let's make the float range as a health setting. I mean we will be adding a header of a health setting. Switching back to Unity to see the update. Here we have the header of health setting above the float range. And what is next? Next we have a multi-line. This makes the string editable with the multi-line text field. Pass an optional int to designate the number of lines. For the demonstration, adding a player description as a string. Switching back to Unity and here we have a player description string and we can type a string here. I'm typing a player description or player details. To get a more space for the typing, I will be using a multi-line attribute. In above of the string, in the square bracket, just simply type multi-line. Switching back to Unity and keep an eye on the player detail area. So here we have a multi-line area now. And now it's easy to type multiple lines of the text. Switching back to script and to add more area, we can add a value to the multi-line. In the parentheses, I'm adding 10. Now we will have more space to type. And now we can type more text easily. To demonstrate the next attribute, I will be adding a few simple 3D objects in the scene. And the next attribute we have the selection base. This is useful for selecting a game object whose children may contain meshes. Add this attribute to any component on the base object. When picking object in the editor, the game object containing the selection attribute gets selected rather than the children. Creating a third object, a capsule, and now in total we have 3 objects. We have the cube as a parent and sphere is the child. And next we are making capsule is the child of sphere. And now the cube is the grandparent. And when we click on the capsule, it selects the capsule, that is the child object. And when we click on the sphere, it selects the sphere. And same with the cube, that is the parent. Let's suppose my requirement is whenever I click on the child object, it should select the parent object. And then I can move around the parent with all the childs, avoiding the mistake of selecting child at the first hand. Adding an existing player script to the cube, we are attaching the script with the parent object. And above the class in the square brackets type selection base. It will make this game object as a base of the selection. Switching back to Unity and now click on this child capsule. But did you notice it has selected the parent cube? And we can move the parent game object with the childs. Let's try it again and moving it. That doesn't mean now we can't select the child object. we can double click on the child to select the child object. But now we have give the selection priority to the base object, to the parent cube, because our parent cube have a script attached that have a selection base attribute. And the next attribute we have is the formally serialized as. The current value is 8 in the integer range. If I will update the integer range variable, we will lose the data or this value, changing it from integer range to the power range. As it's a power setting, so now we have a power range. But on the Unity editor, we will lose the value. To avoid this, we can use this attribute. Demonstrate this, reverting the name back to integer range and setting the value to 5. Go back to your script, and above the integer range, we need to add the formally serialized as. The IntelliSense is not getting it. I guess we need to add the namespace. Let's first add the namespace. Type using Unity Engine dot serialization. And now type the formally serialized as, and in the parentheses pass the old name of the variable as a string. In my case, I have integer range. I will copy and paste it here. And now I can update the new name, that will be the power range. And now we are hoping the new updated name will be the power range, and we will be holding a old value of 5. So it worked. We have power range and the slider is at accurate position, and we have the value of 5. Next we have runtime initialize on load method. It allows a runtime class method to be initialized when a game is loaded at runtime without action from the user. Methods marked runtime initialize on load method are invoked after the game has been loaded. This is after the awake method has been invoked. But keep in mind that the execution order of the method marked runtime initialize on load method is not guaranteed. My class is the non-mono behavior class. We have these two methods, on runtime method load, and the second is on second runtime method load. And we have added an attribute runtime initialize on load method. Switching back to Unity, and as you know, the my class is a non-mono behavior class and it's not attached to any game object in the scene. Enter the play mode and open the console window. Here we can see these messages from the my class methods. And the next attribute we have add component menu. To demonstrate this, let's suppose I have a script that I frequently attach to the game object, and I want to add a new entry in the menus to add a script. Above the class, inside the square brackets, type add component menu, and in the parentheses as a string, write enemy/enemy target. Switch back to Unity and open the component menu, and at the very bottom you will find enemy, and next you have enemy target. It is grayed out because we haven't selected any game object to attach this script. Select the test game object and again open the component menu and go to enemy and select the enemy target. By this we have attached enemy target to this game object. Let's try it again with the new cube object. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. This section highlights the improvements made to artist feature in Unity 2020 LTS and above, making them even more friendly and intuitive to use. 2D and 3D artists, technical artists, animators, and level designers will benefit from shorter waiting times and more efficient in-context iterations. And let's start this section. You can modify the pickability state of the game objects. Similar to scene visibility, use the toolbar to block specific game object for being selected in the scene view. This is useful to avoid selecting and editing an unintended game object in the live scenes. Let's say I have finalized these white lines in my level design and now I don't want to pick them or select them accidentally. Selecting the parent object and clicking on this hand icon, it will make them not pickable. Now let's try to select these white lines. I'm clicking on the lines to select them, but as we can see, these lines are not selectable anymore. Now let's find something else to try this again. First, let's collapse this line object. And this time we are saying the lights are on their final position and we don't want to move them anymore. I'm looking for the light object and making it not pickable by clicking on this hand icon. So now I'm not able to pick up the lights, so they are at their final position. Let's talk a bit more about the icons. This icon means you can pick up this game object, but some of the game objects are not pickable. And this icon means this is not pickable or selectable. And when we hover over the game object, it shows this icon, and that's mean we can pick this game object and we can select and move around the game object. Now we are making this wall of block not pickable. And if we are done with our level design and overall testing of the scene, we can click the parent object to deselect everything. This way everything will be selectable again. We can select these wired lines, the lights and the wall blocks, everything that previously we have made not selectable. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. We have multiple search bars in Unity Editor. The editor contains search functionality for the scene view, hierarchy window, and the project window. First, let's take a look in the hierarchy window search. I want to search for all the stairs in the level. Just simply type stairs in the search bar. It will filter all the game objects with the name stairs. And it's make it very easy to tweak something. And we also have a search bar in the scene window. Let's search for a wall. Let's make it end wall. You can see the filtering is very quick and it's really make the level design bit comfortable. Let's try one more keyword. This time let's search for the floors. We can select the search game object and can make the modification if we want to. And the third search bar we have in the project window. I'm searching for water in the project assets. It will give me all type of different assets that are related to our keyword water. It can be a texture, model, prefab or shader. As you can see, the search is real time. It keeps filtering the assets while we are typing the search keyword. Let's come back to hierarchy window search. We can click on this icon to select the filter type. We have three options: all, name and type. This is search by name. Switching a search filter by type, and now we have a search by type. Now let's go to the project search and search for the keyword shaders. It's giving me the three folders that have the name shaders. At the start of the keyword, type T and colon. By this we are searching with the type shaders. T colon is a syntax if you want to search something by their type. That was a quick overview of searching in the Unity editor. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. Inspector Debug mode helps the developer to investigate or debug within the inspector panel. You can toggle each game object inspector between normal and debug mode. And debug mode also exposes the private variables as well. To investigate, first select the game object. I am selecting a player to reveal the debug mode. Now simply click on this button with three dots and select debug. Now you see we are exposed to more data to investigate. And you can select normal to go back to a normal mode. Going back to debug mode. Entering the play mode. In the play mode, we will be looking into the changes in the values. Here I am moving around in the scene and checking out the level design. In your script, if you have multiple private variables and we want to investigate something on the private variable side, we don't need to make them public or serialized to view the value of the private variable. We can simply change to the debug mode to view the private variable values. You can imagine how much time we can save from this, and there will be no chance for error by making the modification in the script. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. If you want to extend your search beyond the Windows search that we have discussed in the last video, you can find anything in Unity using the Quick Search package. Go to Windows menu and open the Package Manager. And in the search bar, type search. The Package Manager will filter the Quick Search package. Select the package and click on Install. Unity 2021.1 incorporates this functionality into the editor without requiring a separate package installation. You can select the option according to your project size, but for now I'm selecting the default settings. Quick Search package installation is completed. Now let's close the package manager. So now the question is where we can find the Quick Search. To open the Quick Search, go to Help menu and at the very bottom click on Quick Search. On typing a search keyword, it will search the complete project. I want to search for the player and I want to see what we have related to player keyword in our project. As you can see, it's showing us the different type of assets we have in our project that are related to player. Now let's search for the wall keyword. As you can see, it also giving us the results that are in our scene as well. Because Quick Search enables you to search multiple areas of the Unity that includes assets, scenes, objects, menu items, packages, APIs, and even settings. By clicking on this search icon, we can see the list of filter category. We can uncheck that filter category we don't want to search. And in the background, you can see it's updating the results in real time. Let's try some more keywords and see how fast it's working. And changing filters as well. At the bottom we can see more information regarding the search. It's showing us the category it's searching for and how much result it found and how much time Quick Search has taken to search all these results. And using this knob we can also change the size of the results. And reducing the size all the way down, it will show the results in a list. Click on the star icon and click on Create. This is the way of saving the queries. At here we can see the detail of the saved query. It's a good way to save if you have something to search more frequently, so you can save it. We have saved these two queries. We can double click on it to open the query. Just empty the search bar to see all your saved queries. The most amazing feature of Quick Search is we can also pinpoint the object in the scene from our search result. In this example, we are searching for the player query, and in the first result, it's giving us that the player is in the main scene. When we hover the cursor over the search results, it shows us this button with the 3 dots. Click on it and it will show us the 2 options. And you select the first one, select object in the scene, and it will take us to that object. Let's focus that object. Select the player game object and press F. So the Quick Search is quite useful if you need to search anything in your project. Open the Quick Search again. As you can see, the by default Quick Search is not dockable. We can open the settings from here, and these are the settings of the Quick Search. You can also find the settings from the preference window. These are the default provided settings. And at the top, we can check Open Quick Search as a dockable window. Close the settings and open the Quick Search again. So now we see it's movable and we have these 3 buttons like a normal window, and we can dock it as well. Trying the random test keyword, and when the search bar is empty, it shows us the saved queries. We have these 2 shaders and player. So that was all about the quick search. It's an amazing addition by Unity, the editor getting changes rapidly, and of course it's making the life more easier for the developers. I hope this video helps you. If you have any questions, you can always ask me. Thank you for watching, and I'll see you in the next. Hi, in this video I will be showing you the 13 small editor workflow tips that will further enhance your work process and speed up your workflow. The first one is you can also paste the game object as a child from the context menu. Before that, take a look how the normal copy paste works. Right click on this game object and click on paste, and it pastes at the same level of this game object. Or we can drag and drop inside this game object to make it a child. Or what we can do is right click on it, paste it as child. By this it directly make the object as a child. And that was about paste as child. Number 2. How constantly we can observe or view any movable game object. Enter the play mode and open the scene window. In this example, I want to observe the behavior of the player cube. I can use F shortcut key to frame the selected object in the scene view. This now handles more object types and does a better job for framing them. If I keep pressing F, this is how it looks. Or what we can do is press Shift plus F to lock onto the selected game object that is moving. So this way we can see the behavior of our moving game objects. Pressing Shift F again. And that was all about focusing on moving object. Number 3. We can view the 3D model, UVs, normals, and other mesh related information right inside the inspector, and also the vertices and triangles of that 3D model. Click on 3D models, and using these 4 tabs you can view the basic information of the 3D model. First tab have the model related information, and second is for the rig, and in the third we have animation, and in the fourth we have a material related information. You can click on this button to view the model in more depth, and you will see the different key components of this 3D model. For now we are more interested in the mesh part of this model. Reducing this knob to view in the list view. Here we have different mesh information, vertices, indices, skeins, and other. Making more space for this window so we can have a better look. By clicking on the wireframe button, we can turn on and off the wireframes. For now, I want the wireframes. You can click here to open the different option for this mesh and select the UV checker. And using this knob you can change the check size. Open the list again and this time select UV layout, and this is the layout of this mesh. Open the list and now select normals. And now selecting tangents. And this is how it looks. Going back to shaded view, and this was all about the mesh different informations, and it really helps to understand your 3D model for your project. If you are working on a mobile project, and it really helps to understand is it a low poly model that fits in your project. At number 4, now we have improved inspector to preview for 3D textures such as volumetric rendered 3D textures, slices, and sign distance field. Converting my texture to 3D. Click on apply. Now we have converted our texture to a 3D one. This one is a bit heavy to preview. Here I'm trying to move it around. Using this knob, we can change the alpha of this texture. Changing back its angle to the front. So that was a quick overview of Inspector Preview for the 3D textures. And next we have number 5. We can use Layers menu to toggle off visibility of any layers, such as UI or that may obscure your scene view. Lock a layer to avoid changing its state accidentally. You can open the list of layers by clicking on this drop-down button. Clicking on the eye icon in front of nothing to show nothing in the scene. Clicking here to show everything back. Turning off default layer, showing me almost nothing because everything is on default layer. For now, having the default layer on, let me find the right angle to view the UI in our scene. So we will turn off the UI to see the impact. Disabling and enabling the UI layer. In this scene, everything is at default layer. For the testing purpose, I will be changing the wall layer to ground and then I will disable the ground layer. Select the wall and click on ground layer. Select yes to affect the children's. And now open the layers and disable the ground layer. We have all the game objects enabled except the ground layer, assigning the ground layer to one more part of the wall. Disable the ground layer again and see the effect. This way we can handle the game objects as a category. It's recommended to add layers to everything. Every light should have the lighting layer and ground have the ground layer. Then it make it very easy to explore different part of the level. That's it for the layers. Now we have number 6. If we have the finalized layer of the objects, now we will see how we can lock them so we can avoid accidental changes. By default, I can select different objects and can make changes in them. Selecting this wall block and moving it around. By default, this wall of chunk is at layer default. Now I'm going to lock the ground layer. I will still be able to move around the wall because it's not in the ground layer. Let's try changing it to ground layer. And select yes. Now we are not able to select all the objects that are in the ground layer. But I can select all the objects that are in the other layers. Using the layer locking, we can avoid the accidental changes. It is very helpful on a complex level design. And that's it for the layer locking. At number 7, we have selections. If you select the same object in your scene more frequently, we can use the selections. Selecting structured game object, go to edit and then selection and then select the first. Save selection 1. Clicking here to deselect everything. Now press Option Command 1 to select the selection 1 that we have saved recently. And now for the second selection, I'm going to save the line object. Selecting the lines, go to Edit and select Selection and save selection 2. In the selection menu, all the commands are written in front of each selection. This time saving the water plane at the selection 3. Now we have saved 3 selections and we can quickly access them using Option Command 1, 2 and 3. We can also select them manually by going to Selection menu and click on Load Selection 2. It's a very rapid way of selection. And getting used to the command is really boost up your working process. And that was a quick overview of the frequent selection. At number 8, we have numbering scheme for the duplicate objects. And this is the default way Unity assigns numbers to the duplicate objects. In the braces, we have 1, 2, 3 and so on. We can modify this by going to Project Setting and select the editor. I'm docking it here beside the games. Selecting the editor and at the very bottom you see the numbering scheme. Here we have 3 types of numbering. Selecting the second one, and now when we are duplicating the game object we see dot 1, dot 2, 3 and 4. Let's also try the third scheme. Duplicating and we have underscore 1, 2, 3, 4. Selecting the second scheme again, and we also have an option of game object digits. Using this, we can further modify the numbering system. I will be making it 2 so we can have 2 digits after the dot. Duplicating the objects, and we have .01, .02, .03. And the same way we can extend it up to 5 digits. Now we'll be duplicating, we will be having a 0.0001 and so on. That's it for the numbering scheme. At number 9, we have tagging the object editor only. Use the editor only tag to designate the game objects that will not appear in a build of the application. Selecting a game object corner wall 4 and randomly repositioning it and making it editor only, as I'm using this object only for the experiment purpose, and it will not show in your final build. And that's it for the editor only tag. And number 10, we have Unity editor color in the play mode. Click on Unity, open preference and select the colors. And here we have a player mode color and we can change it. Click on the color bar to open the color panel. Select your desired color and close the panel. And there are tons of other options, you can change their colors as you want. For more color experiment, I'm keeping the preference window here. Click on the play button to enter the play mode. As you can see, as we enter into the play mode, Unity editor color has changed to red that we have selected recently. It's kind of giving us an alert that you are in the play mode. And be active if you are making changes, you might lose the changes. Let's try a few other colors. That's it for the colors. And at number 11, we have copying the values when we are in the play mode. Select your game object, copy the transform component, and the second way is you can drag and drop the player cube into the project view to make a prefab of it. And then later we can get the values out of the prefab, as prefab will stay even after we exit the play mode. And the transform component we have copied during the play mode, we can paste it like here, paste component values. That's it for the copying values. At number 12, we have align with view. Select your desired angle in the scene window, and we will match the camera with that angle. Go to game object and click on align with view. Now we have camera is looking at exactly the angle we have in the scene window. We can also match the view according to the object we have selected. Go to game object and select align view to selected, as now it is aligned according to the object we have selected. That's it for the align with view. At number 13, we have Unity editor layouts. Click here and select 2x3 to change the overall layout of the Unity editor. Every layout of this editor is useful. You can change the layout according to your project need. After selecting a specific layout, even we can further customize it according to our need. Let's try another layout, 4 split. Mainly it has 4 windows on the left side. It can be useful in many situations, especially when you want to see any game object from different angles. In the project window, if you want to see the assets in the list view, you can reduce this knob. Opening the default editor layout. In my previous videos, mostly you have seen this layout. Opening the tall layout. Personally, I like to work in this layout. Maybe I guess because I get more space to work on the scene. In this layout, the inspector window, hierarchy, and project windows are much closer to each other. And it saves me a time of moving cursor from left side to the right side. And when I need to assign something, it gives me the less travel time. Open the layout, and now let's try the white one. Further, we can also customize the layout, and we can save our customized layout. Let's customize it and then we will save it. We are done with our layout, and now it's time to save the layout. Click on this button and click on Save Layout. Enter the name of the layout and click Save. Now before selecting our customized layout, I will be randomly shifting this layout. Opening the layout list and select default. This is the default. Now select my layout. So that is our customized layout we recently saved. We can also save the layout to the file, and then we can re-import into the other project to reutilize it. And this is the way of loading layout from the file. Click on load layout from the file. Click the file and select open. It will load the layout from the file. We can also delete the layouts by going to delete layout and select the layout to delete. Click on delete and my layout is gone. And by chance, if you did a lot of mess with the layouts, you can always reset all the layouts and select continue. And that's it for the layouts. In this video, we have seen multiple techniques to enhance and speed up your work process. These were a small enhancement, but in a combination, they are very powerful. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. Many projects, especially 2D projects, uses sprites to create its visuals. These potentially contains many textures assets and may thus require many draw calls. To optimize this, we can use Sprite Atlas. A Sprite Atlas packs several sprites into a single combined texture. These are the different sprites I have in this project, and these sprites are only in the weapon category. We can click on any sprite to view in the preview window, or we can double click on it to view in the image viewer. And this sprite is 4x. Now I will be showing you the Sprite Atlas folder, and there we have Sprite Atlas for each category. And this is only for weapons, and we have combined all the weapon sprites into this Sprite Atlas. And these are with the extension .sprite atlas. And further in the inspector panel, we can see more detail of it. And these are the list of objects for packing. Basically all the sprites that are combined into this texture. Resizing the preview window to have a better look. Let's take a look at another Sprite Atlas. So next is Sprite UI Battle. As its name suggests, it has the sprites that are related to battles. And next is for environment or the level design. And these are the several other Sprite Atlases that are used in this game. To make most of the 2D projects, we require to use hundreds of 2D sprites. And that's why to optimize it, we use Sprite Atlases. Let's have a look at this amazing 2D project. Everything you see in this project are 2D assets. It will give you a rough idea of 2D game and how many different sprites are worked together to make this experience. The use of lights are amazing in this project, and I'm sure you must be identifying different weapon sprites that I have showed you. And this is very nice running animation using the sprites. And next it will be loading a data from the UI Battle Sprite Atlas. The gameplay is very simple. They will fight with each other and the survival team will win. The left side we have our players, and once their energy circle get filled, I can click on it to make a bigger impact. This one is ready, clicking on the wedge. Now let's take a look how we can create a Sprite Atlas. Open the asset menu and go to create and then 2D and then at the last Sprite Atlas. Enter the name of the Sprite Atlas. I'm making 4 buttons, so writing the buttons. So here we have our brand new Sprite Atlas. Locking the inspector window to keep it while I'm selecting the sprites. And I want to pack these 4 sprites. Dragging and dropping it over object for packing. We can preview by clicking on Pack Preview. Resizing the window to have a clear look. We can delete the individual sprite by selecting it and clicking on this minus sign. Click Pack Preview to update the preview. Now we have 3 sprites. If we have few sprites, we can also reduce the texture size. If you're going to select to lower size, it will give you a packing error. And in this case, it's giving us error and also suggesting it needs at least 512. So selecting a 512 pack preview. By this we have cut the extra space on the Atlas, and also the Atlas size is reduced to 256 kilobytes. And before this it was a half megabytes. And the regarding sprite, few more tips. Adding sprites into the object for packing list, and enable include in the build to include your sprites with your project. Use the packing option to determine how closely the sprites can be laid out in the Atlas and whether they can be rotated. Once the textures are consolidated, Unity can issue a single draw call to access the packed texture with a smaller performance overhead. A Sprite Atlas can reduce the draw calls if you organize the UI layout correctly. Unity scans the game object hierarchy top to bottom in order to batch objects that use the same texture and materials. The Sprite Atlas API provides additional controls at runtime. You can also create a variant Sprite Atlas or prepare the Sprite Atlas for an alternate form of distribution with late binding in a script. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. Prefab allows fully configured game objects to be saved in a project for reuse. The current workflow with prefabs lets you build your scenes flexibly and efficiently. In this project, we have a separate prefabs folder, and each folder contains a category of prefabs, and these are the different prefabs that are used in this game. It's a dragon prefab, and we can double click on it to edit the prefab. The prefab hierarchy will be opened in the hierarchy window. And here we can edit the prefab. We can add or delete things from the prefab, and it will have the effect on the entire game, wherever in the game this prefab is used. And these hero characters are also prefabs. In the scene, the game objects with the blue color, they are prefabs. In this scene, everything is almost prefab, because prefabs are easy to manage and update. By using prefabs, we don't need to update the objects individually. Further, in the project window, I would like to highlight that this is the base prefab, and these prefabs are override the base prefab. So these prefabs, dragon, knight, skeleton, witch, wolfman, these are all overridden from the unit base prefab. In the hierarchy window, we can open any prefab by clicking this arrow, and then we can modify the prefab. And this drop down shows how the prefab is different from the original. By clicking this arrow, we can go back to the scene. Now let's talk about what is nested prefabs. It allows you to parent prefabs to one another. You can also create a larger prefab such as a building composed of smaller prefabs for rooms and furniture. This makes it efficient to split development of your assets over a team of multiple artists and developers who can all work on different parts of the content simultaneously. And what is prefab variant? It basically allows you to derive a prefab from other prefabs, much like an inheritance in the object-oriented programming. To change the variant, just override certain parts without worrying of impacting the original. You can also remove all the modification and revert the base prefab at any time. And this dragon prefab is also the example of the prefab variant, which is inherited from the base prefab. And of course, if you want to change all of your variant at once, apply changes directly onto the base prefab itself. The beauty of prefab variant is that each prefab variant have different weapons and ability, and now that makes the prefabs a lot flexible. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. The TextMesh Pro replaces the Unity UI text and the legacy text mesh. It uses custom shaders and advanced text rendering techniques to deliver flexible texting style and texturing. Click on Game Object, UI, and Text. This is the older version of the text in Unity. Renaming it old text. Open the scene window and this is how it looks. Repositioning a bit. And these are the components available in this text. It's not a new now, let's make it old text. And these are the few basic settings for this text. Enabling the batch fit, changing the color to white. And that's pretty much of it. If you already don't have the TextMesh Pro, you can install it from the package manager. Open the package manager, clearing out the previous search and looking for TextMesh Pro. There it is, TextMesh Pro. I have already installed it. Closing the package manager. And now I will be creating a text with the TextMesh Pro. Open a game object menu and go to UI and TextMesh Pro. This text is for the UI. We also have a text with TextMesh Pro for the 3D space. And this is the TextMesh Pro component with these options. We can change the font size, repositioning the text, making the X and Y 0, and selecting the anchor at top center, and readjusting the Y. We can make the text bold, we can make it italic, or underline, or strike through, and lowercase, uppercase, and small caps. Auto size option, of course the basic color option, and we also got a color gradient option. Here I'm trying few random colors. And we have spacing option with characters, word, line or paragraph. Now adjusting the rect transform. And we also got a few different alignment options. And this is the shader used for TextMesh Pro. Using the TextMesh Pro, you can achieve a lot of design. And here I'm showing you the few sample text from the sample project. So you can get the idea what you can do with the TextMesh Pro. Again, trying a few color combinations. And you can see how drastically it's changing the look and feel of the text. And here you take a look at few other UI elements that are using the TextMesh Pro. You can also create a 3D text by going to a game object, 3D object and selecting the text TextMesh Pro. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. Using snapping, working on a grid helps you fit your prefabs together with less guesswork and greater consistency. Design your levels so the pieces connect at scale, making it easier to rearrange and reassemble them. Normally we grab these handles and try to position our game object. The repositioning value of the cube is changing continuously. And by this, it's very hard to align the object with others. And that's where the snapping comes handy. Unity provides three types of snapping to help you assemble your scene quickly: world grid snapping, surface snapping, and vertex snapping. First, let's take a look on the world grid snapping. Make sure the Move tool has the handle orientation set to global. Hold Control for Windows and Command for the macOS to snap an object to the world grid. Duplicating the object, and I will try to align it. It's very hard to align this way. Better way to hold the command and move it. Now they are perfectly aligned with each other. Duplicating one more cube. Take a look how perfectly they are aligned using the snapping. And at the same time, it is easy and quick. This time I'm trying to snap above the cube. Adding one more on the top. Also extending at this side a bit and on the top side as well. To get more control and more customization over the grid, you can also change the grid increment by going to Edit and clicking on Grid and Snap Settings. If you have 1 here, that means move the object 1 unit when you increment. For the demonstration, I am changing it to 2. I am docking this bar here, maybe I use it again. And now this time moving the cube, it should move the 2 units. Okay, nice, it's working. As you know, the cube size is 1 unit. When it's moving 2 times, it's giving a space between of 1 cube. Changing the value back to 1. If you are constructing your scene from the modular assets, use grid planes to align your game objects with each other. Rather than manually typing in around the numbers into the inspector, consider letting the grid snapping tools set your transforms more quickly and precisely. Next we have surface snapping. Hold Shift and Command for the macOS and Shift and Control for the Windows to snap an object to the intersection of any collider. I think it's a very handy tool for the level designers in many situations. Let's try this placing same cube on the walls. The detecting of other object collider is very smooth. And the third we have vertex snapping. Hold down the V key while the move tool is active. This moves the current game object to the vertex position of another mesh. Before moving, hover the mouse over one vertex of an active game object. To move that vertex, act as a pivot. Shift V, toggle vertex snapping mode on and off. In this example, I'm picking a cube from the corner and matching it to the other object corner. It's a handy tool when you need to match the object with the vertex. And now you know these techniques, you can also combine vertex and surface snapping for quick placement. Move the game object using vertex snapping with the V key or Shift V. Hover the cursor over a vertex as a pivot. Snap to another vertex as usual. Hold down the Shift and Command key to drag along the surface of the target mesh. Release the mouse button and V key once the object is at the desired location. From here you can open the grid settings, and from this slider you can change the opacity of the grid. And can change the grid axis by selecting X, Y or Z. Reverting it back to Y. And by clicking on this grid icon, we can turn on and off the grids. And you can also try these commands for the grids. Click on Tools and select ProGrids and then ProGrids window. And this is the new extended toolbar of the ProGrid. Need even more controls? Then consider using the ProGrids package for even finer control of your snapping and grid planes. You can install this package from the package manager. Using ProGrids, you can also render a 3D grid for the perspective mode. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. You can animate just about any property in Unity without writing a single line of code using animation window. In addition to modifying movement, you can even drive parameters defined in your custom scripts. Open the window menu, go to animation and select animation, or the shortcut key Command 6. Docking the window at the bottom. These are the list of all the animations of this character. You can open the list by clicking this drop down and select any animation. At the bottom, you can shift to top sheet or to the curves. We can click this play button to play the animation. Changing the animation to jump. Switching to top sheet. And these are all the animation points. And these are the different character components values that are changing with the animations. Select your character and go to animator. Double click on assign controller. We have free animations and let me focus on this controller visuals. The animator controller links the animation clips in a visual graphs. Once you have several animation clips for your game object, the animator controller acts as a state machine to create a flowchart like a graph between them. This allows the artist to produce sophisticated animations with greater independence from the programmers. If you are using a 2D or 3D rig, you can animate its body parts with different logic. Take advantage of layering and masking features for greater control. Prototype your motion in a visual programming tools to fine-tune any transition or interaction between your clips. If you are working with characters, make sure your animation rig type is humanoid. Select your 3D model and go to Rig. In the animation type, you have 4 options. Make sure you have selected a humanoid for the character animations. And these 4 tabs are for your model different settings. We have Model, Rig, Animation and Materials. By clicking on this arrow, you can further open your 3D model. And it have a basic rig, skin, mesh render and the mesh. And from the mesh part, you can see the number of vertices and indices of the 3D model. That was a quick overview of built-in animation and controllers. And if you want to try and extend the more of the animation side, then you can try DoTween. It's an amazing asset for the animations. And it's free to download and use. You will not find it directly in the package manager. Open the Unity Asset Store from the web and add this package to your account. And then in the package manager, go to My Assets and there you will find this package. As it's not provided by Unity, so it's not in the package manager by default. And few more optimization tips. Extend this further using the animation rigging package. This package provides a library of rig and inverse kinematic constraints that can create a procedural motion. Animated skeleton can thus interact with the environment with the runtime rigging, or physics-based constraints can add dynamic secondary motion. And you know that the constraints can modify your animations at runtime. Now, as we know, the animator controller offers convenience, but be aware of few things that avoid overusing animators, particularly in the conjunction with the UI elements. Animator calls the UI canvas to rebuild each frame, even if no animation is playing. Whenever possible, use the legacy animation component for the UI or simple animations. Also consider creating a tween functions or using a third-party library that I have shown you, the DoTween. And one more thing, by default Unity imports animated models with a generic rig, but developers often switch to the humanoid rig when animating a character. Just keep in mind a humanoid rig calculates inverse kinematics and animations, retargeting each frame even when not in use. If you don't need these specific features, save on the CPU time and use the generic rig. As we are talking about the animation, further you can also explore the topics, animation clips and animation controllers from the Unity documentation for more detailed use. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. This video is about custom gizmos and icons. Gizmos are small overlay graphics associated with your game objects. Use them to navigate the viewport or locate specific objects. Select the game object and click here to open the icons and choose any icon for this game object. Similarly, selecting this game object and marking it with the orange diamond icon. This way we can mark some specific category of game object, so later you can easily identify the one category of the game objects. And we can mark any game object in the scene. These bigger icons are useful if you want to also show the name of the game object as well. Assigning this game object orange, and we can see the name is Wood Impact. It makes it very easy to identify different kind of objects. If you have a complicated scene or a scene with hundreds of game objects, these icons resize itself when we came closer or go far away. And when we are too far away, they hide themselves so it doesn't create a mess in the screen. Selecting this cube and assigning a small icon to this. And we can also select the custom icon, select the object, open the window and click on Other and select the icon you want. I have chosen the icon randomly. Now this cube have a custom icon. This plus sign is a custom icon for this particular cube. And if you already have an icon, we can also remove the icon by clicking None. Removing icon from this cube as well. Using this gizmo menu, we can enable or disable different type of gizmos, and we can turn on or off all the gizmos by clicking on this gizmo button. You can also create gizmos with script and make them interactive. For example, a gizmo could help you define a volume area of influence or for a custom component. And that was it for the gizmos and icons. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. Light mapping allows you to pre-calculate both direct and indirect lighting, then store the result in a texture called Lightmap for later use. Unity offers a number of global illumination or GI techniques to produce high quality lighting and shadows. Though Lightmap geometry is performant at runtime, baking a Lightmap has historically been expensive. The progressive Lightmapper is a fast path tracer that produces a quick result, then refine the render over time. You can thus interrupt the process to make changes without waiting for the final bake to complete, and it allows you to iterate more rapidly. And you are looking at the final result after the light map is baked. To open the lighting setting, open the window menu and go to rendering and select lighting. It will open a new lighting window. I will be docking it here. The scene you have just watched, these are the lighting settings for that scene, and of course you can modify it according to your project need. In the Lightmapper you can choose the progressive setting for CPU or GPU. The progressive GPU is in the preview version. Selected a lighting mode as Bake Indirect, and we also have two other options. I have tested the progressive GPU for this video and it's working great. Select Advanced in the filtering option. Review these other settings and click on the generate lighting. And we can also clear the existing baked data. At second, we have environment tab, and at third, we have the baked light maps. And here we have a bit more detailed 6 direction light maps, and a size is 64 megabytes. Clearing the baked data for the testing purpose. And to show you how the drastic difference we have without the light maps, click on this maximize button to maximize the screen on play. Click on play to enter the play mode. And this is how the scene looks without the light mapping. And here it's showing the FPS. We are getting 26 at the moment. It's because of the recording screen. I am easily getting around 40 with this scene using Apple M1 chip. Take a look to see the difference, and next we will be baking the light maps. Exit the play mode. And make sure all the settings and click on generate lightings. On pressing the generate lighting, it will extend the window from the bottom to show you the detail of the light maps. And at the bottom right corner, the progress will start and it will show you the time as well. And to further open the detail window, you can click on this progression. And it will show you the detail of the current step and the overall percentage of the completion of this task. But the time you are looking is not accurate for now. It will take some time to get the idea of the overall task, and the time will change, and usually takes a good amount of time. This type of scene can take up to an hour or maybe more than an hour. And now let's see the difference between baked and unbaked scene. Here are few tips to speed up your light mapping. Enable the prioritized view so the progressive light mapper works on the texels currently visible in the scene view first before changing anything outside of the view. Reduce the unnecessary samples, direct or indirect samples, and bounces 2 is usually the sufficient, only increase if necessary. Optimize the light resolution and texel count for the light needs. The number of texels represent how much work your light mapper needs to do. Because light maps are 2D textures, and doubling the light map resolution quadruple the amount of work. And the next is reduce texels on the hidden surfaces, small or thin objects, or anything where the light map won't make much impact. Each mesh rendered contributing to the global illumination has a scale in the light map, option to reduce its relative UV size in the light map. And next is choose a proper light mode. You can choose baked indirect, subtractive, or shadow mask. You don't need to bake shadows if you don't require it for your art direction. And the next tip is the current progressive CPU light mapper uses your machine CPU and RAM. The newer progressive GPU light mapper use your GPU and VRAM, potentially speeding up the bake considerably. If your computer meets the hardware and software requirement, this can dramatically speed up your lighting workflow. Lightings are crucial in any project, and they play a very important role in success of any project. And that's it for the light mapping. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. In this video, we will talk about the light props. Global illumination produces beautiful indirect lighting, but this can be expensive to calculate and store on the disk. If you have set dressing or other static meshes that don't absolutely require light mapping, consider removing them from your light map bakes and use the light props instead. The light baking settings are the same that we have seen in the previous video, just showing you for the quick review. In this example, the light props could approximate both direct and bounce lighting for the smaller objects, reserving the higher quality light mapping where it's more noticeable. And this is the light data asset. These are the light maps applied to the Viking Village project by Unity. In the scene, click on this light props, and these are the light props in the scene. Use light props for the smaller details where light mapping is less noticeable. Formerly reserved for dynamic objects, light props can apply to static meshes as well. And you've seen the 3D models have the mesh rendered component attached. Locate the received global illumination dropdown and toggle it from light map to the light props. By this, you are shifting the load from the light maps to the light props. The light prop illumination does not require proper UVs, saving you the extra step of unwrapping your meshes. The spherical harmonics basis function used in the prop lighting make it fast to calculate relative to the light mapping. In the scene, we have made all the non-moving objects as static. Arrange light props and light prop groups, especially in the scene. Prop lighting typically bakes faster than the light mapping. These yellow circles are the light props, and we can add more light props by clicking here, Add Prop. We can select them and readjust them. From here we can select all. From here we can delete the selected, and from this button we can duplicate the selected light prop. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. Unity has evolved its native 2D tools to help you develop faster and save time with these helpful tips. The first is 2D Pixel Perfect. Install the 2D Pixel Perfect package from the Package Manager. Open the Package Manager. Click on 2D Pixel Perfect. It's available within Unity registry. Select and install the package. It also have a samples. Let's import the samples as well. Close the Package Manager window. And open the sample scene from the 2D Pixel Perfect. I have opened the sample scene sprite render example and also changed the layout to tall to better view the sample scene. This is the Pixel Perfect camera and its settings. Selecting a hero sprite renderer. Select any sprite to view the sprite setting. And this is the sprite setting for the Pixel Perfect camera. Sprite mode is single and filter mode is at point no filter. This Pixel Perfect camera that ensures your pixel art remains crisp and clear at different resolutions, so you can avoid manual scaling of your art assets. And let's try a few different screen resolutions. That's it for the Pixel Perfect camera. The second is 2D PSD importer. Open the Package Manager to install the 2D PSD importer. Searching for PSD, select the package. For my case, I have already installed it, so I will be updating it. Click on Update. Closing this window. In the project window, search for PSB. PSB is basically a Photoshop big file format. These are all the PSB files. We can view the file in the system folder by clicking on Reveal in Finder. Here we have psb_character_night.psb file. We can open this file from within Unity by double-clicking on it. On my system, it's opening a file in Affinity software. It's an alternate of Photoshop in Mac. Mainly we use PSD importer package if you want to work with the Photoshop file assets, skipping exporting separate sprites and import a .psb file. A PSB file supports larger images than more common .psd file format, but its functionality is the same. This allows you to import multiple sprites from various layers and generate a sprite sheet or 2D character rig. And we can open a sprite editor by clicking here Sprite Editor. And from here we can modify and view different settings of the sprites. That's it for the PSD importer. At number 3 we have tile maps. Use tile maps to create large grid-based worlds including hexagonal and isometric versions, optimized for size and performance. In this tile map example we have two grids component, dungeons and water. Take a look at the dungeon game object. It have these several components attached. When we select a tile map, here it shows a button to open a tile palette. And we will be docking this window. Next, I will be showing you how it is easy to modify the tile map level. From the tile palette, select the paint tool and the active tile map. And by just simply clicking on the grid, we can add more dungeons, or we can click and drag to modify it. Now adding more dungeons. And now let's try the water. So you see how easy and cool it is to modify the tile maps. Quickly finalizing the level and we will try to play it. And we can move around in the level. I think it's too narrow here. But the point is you get the basic idea. And that's it for the tile maps. At number 4 we have 2D skeleton. Create smooth 2D skeleton animation with rigging, tessellation and bone creation. 2D IK simplifies animation, calculation and how your 2D bones can reach their target destinations. In this example I am showing you the fully rigged 2D character. And using these knobs we can test the character target limits. And we can also create amazing animations. I will be testing a bit this character to see how different type of animations we can get. We can also click on the body part to view the actual sprite. And can change the color scheme in IK Manager 2D. To differentiate different body parts. We can have different sorting layers and from here we can change the layers. And we can also change the weight of the character. And that was it for the 2D skeleton. Next we have 2D lights. We can enhance the visuals with lights. Light feature easy to configure parameters like light colors, intensity, fall off, and blending effects. To add a new light, go to Game Objects, Light, 2D and Freeform Light 2D. And these are the basic settings of the light. We can change the light color, modify intensity, and these knobs to change volume opacity, shadow intensity and shadow volume intensity. And now I am trying few random settings. Lightings have ton of options. You can easily match the requirement of your project. I have selected this light bulb to try out other settings. And this light bulb have a light type of point. Take a look how intensity changed the overall feel. Let's try a few other colors to change the feel. And I really like the inner and outer angle feature. Using these, you can create amazing lighting effects. And to make a bigger impact, we can change the lighting type. Selecting Sprite, selecting Freeform, and Parametric, and Point Light. I will be keeping these light modifications. And let's play the game to see the difference and other lighting effects. Lighting and sounds are very important in success of any game. They play a very major role. And that's it for the lighting. And number 6, we have 2D Sprite Shape. 2D Sprite Shape gives you the freedom to create rich free-form 2D environment with a visual and intuitive workflow. It tiles the sprite along a shape's outline, automatically deforming and swapping them based on the outline angle. And that's how simple it is to edit the splines. And can use the outer knobs to twist the sprite. And this first knob to reposition the starting point. And this is the last point to match with your environment. And adding a new point is also very simple. Simply click anywhere on the line to create a new point and modify from there, creating a one more point. And we have 3 tangents more to edit the spline. Pressing Ctrl Z to reset. And trying out the first one linear. You can also change the corner threshold. And can also change the position. It's a very useful tool to create a shapes rapidly. How we can create a new shape? To create a new shape, go to Game Object, 2D Object, and Sprite Shape, and click on Open Shape. It's our new shape and we can modify it just like we did it before. Select your shape and in the Sprite Shape controller, click on Edit Spline. Can change the color from here. Finalizing the color and randomly deforming the shape. This is the first option, that is open shape, and we also have a closed shape. Creating a new point is also easy. Just click anywhere on the line to create a new point. To create a closed shape, go to Game Object, 2D Object, Sprite Shapes, and select Closed Shape. So this is the closed shape. In this shape, our line is connected. Editing the shape is same as we added the open shape. We can change the position of the dots, or we can create a new point by clicking anywhere on the line. The editing is just the same. And that's it for the 2D shapes. And next we have sprite sorting. Sort your sprites based on your preferred direction. This can be helpful if you have number of sprites within the same layer and sorting order. Imagine a card game where the individual card overlap a bit. Go to Edit and open the project setting and go to Graphics. Currently it's in the Universal Render Pipeline asset. We need to change it to a built-in render pipeline. For that, simply we will select None. And now we can see the camera settings with transparency, sort mode, and axis. For the mode selection, we have 4 options. I will be selecting custom axis. For example, X0, Y1 and Z0 for the transparency sort axis to sort along the Y axis from top to bottom. And that was it for the sprite sorting. And next we have 2D shaders. If you need custom shaders, shader graph include 2 master nodes designed for 2D sprite kit and sprite inlet. Create 2D shaders and enhance your 2D project visually. To create a 2D shader graph, open the menu, go to shaders and go to universal render pipeline and select sprite lit shader graph. Select your newly created shader and click on Open Shader Editor. This is the graph editor to create or modify your shader. And now I will be showing you the few shaders that are used in this 2D sample project. This shader graphic folder have multiple shaders that are using for different purposes. This one is used for the lava wave and this is for glow. Searching for a lava shader to show you a complete sample shader. Taking this window to the right to make some space and we can zoom in and out. And from this list we can access the different properties of the shader. And you can modify these parameters to get your desired result. This is for changing the number of tiles. And this is to change the speed. And that's it for the 2D shaders. And the next topic is how we can avoid overdraw to improve the performance. First, we can observe the area in the scene view and we can identify the sprites. To observe the scene view, click here and select overdraw. Observe the scene carefully and look for the brighter areas. The brighter area will having a more overlapping. And you can also switch the type to tight in the import setting for each sprite, merge overlapping graphics in a single sprite whenever possible, and to try to disable sprites that could be in the background layer with no use in the game. This reduces the overdraw area and potentially overlap the neighboring sprites. That's it for it, and next we have Sprite Editor. Select the sprite and click on Sprite Editor. It will open the Sprite Editor window. Select the custom outline and click on Generate. By this you can also consider defining a custom outline around each sprite using the 2D Sprite Editor to minimize the unused area. And for the bigger project, it definitely enhances the performance. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. In this video, we will be creating a custom menu, and using that we will take a screenshot. Unity includes a simple way to customize editor menus and menu items, the menu item attribute, and you can apply this to any method in your script. If you have a function for your project that you will use frequently, organize them into a menu item. This allows you to build a basic user interface with just a single property attribute modifier. Create a new script with the name of Screenshot Taker. For this video, I will be demonstrating a custom menu with Screenshot Taker. Open this script and we will be reviewing the code that I have already written. Now pasting the code, and this method will take a screenshot of the game view, and it's a non-mono behavior class, and we will be using Unity Editor, System and System.io. At line number 11 and 12, checking for the directory. If it doesn't exist, creating a new one. And it's taking a screenshot using a screencapture.capture screenshot and passing the file name with the date. And next we will be linking this with the custom menu. And remember, it's a static method. Above this method, in the square brackets, write menu item, and in the parentheses pass the custom menu hierarchy. Here we are saying the My Tools is the main parent menu, and after the slash we are writing a screenshot, and the screenshot will be the actual button that we will press to take a screenshot. Actually, let's make it take screenshot. That's it on the script side. Now let's open the Unity. Here we have a new menu with the name My Tools. Open it and click on the take screenshot. By clicking it, it will save a screenshot in a project in a screenshot folder. To view the saved screenshot, let's open the assets in the Finder. And here we have our screenshot folder. Let's open it, and there we have our actual screenshot. As we can see, it's the same view that we have in the game window. Let's open the screenshot. And now I will be adding few random 3D game objects to build a basic scene, and then we will take a screenshot of that. And now let's take a screenshot again. Open the My Tools and click on Take Screenshot. To view the actual screenshot, the process is same. The screenshot folder, it's not inside the asset folder. It's in the main project folder where we have the asset folder as well. So now you see how the custom menu is working. And now let's say we need one more button in the My Tool menu and for some functionality, and we will be creating a static method for that functionality. Let's say I want to smooth all the meshes. So I will be creating a method smooth all meshes. For now, I'm not writing anything in it. It's just a dummy method to test the custom menu. Quickly copying this menu item line and pasting it here, and just changing the name after the slash. Let's make it smooth all meshes. And now switch back to Unity, and now we should have two buttons inside My Tools menu. And that's it for the custom menu. I hope this video helps you. If you have any questions, you can always ask me. Thank you for watching, and I see you in the next. In this video, we are looking into custom windows and inspectors. One of the Unity's most powerful feature is its extensible editor. That means we can extend the Unity editor according to our project need. You can also use the UI toolkit package or the IMG UI to create editor UIs such as custom windows and inspectors. To install the UI toolkit, open the package manager. Click on this plus sign and select add package from the Git URL. And type com.unity.ui and press the add button. It will take a moment to install the package. Right now the UI toolkit is in the preview version. Click more to read the detail of the package. UI toolkit has a workflow similar to standard web development. Use its HTML and XML inspired markup language, UXML to define user interface and reusable UI templates. Then apply the Unity Style Sheets USS to modify the visual style and behavior of your UI. UI toolkit samples are available, so we installed the samples as well. Let's close the package manager. And next we are installing UI Builder. Open the package manager. Click on this plus sign and select add package from Git URL. And here type com.unity.ui.builder and press add to install the package. We have installed both UI Toolkit and a UI Builder. The UI Builder lets you visually create and edit UI assets such as UI document and style sheets, and that we use with the UI Toolkit, and import all the samples of UI Builder. One more thing, just keep in mind that the UI Builder is just a visual tool for the UI Toolkit. It does not include any runtime support. To enable the runtime support in Unity 2020.1 and later install the UI Toolkit package. First, let's create a UI document. There are multiple ways of creating a UI document. Right-click on the hierarchy view and go to UI Toolkit and select UI document. We have three options in the UI document: panel settings, source assets, and the sort order. Next, we will be creating a visual tree asset and we will assign it to the UI document source asset. As you see on the UI document, the source asset was empty. Select the folder, go to create, and in the UI toolkit, click on UI document. It will create a new UXML template and press enter and click on save and select the location to save the file. And now the UI builder will open, or you can open by opening the UXML file. And this is how the UI builder window look like. Here we have all the controls and the library, and we will stick together everything in the hierarchy window. Now let's assign the new UXML template to the source asset, drag and drop the file. Rearrange the UI builder. And this is our canvas, and this is how the UI will look like. We can zoom in and out, or we can click on this fit canvas to fit the canvas. Now let's add the visual element. It's just empty, it will hold the other controls. When we hover the mouse over it, and it shows the area that is being selected. By default, the size is set to auto, but we can set it manually. I'm setting it 50%. And keeping the height is also at 50%. And the results are updating real time. And next I want to set the position, looking for the position option. And it's up somewhere. Here we have the position. I will be setting a 25% margin on each side. So I will be writing a 25% left, top, right, and bottom. By doing this, our visual element will be at center. In case if it didn't refresh, you can hover the mouse over it, or you can click on the visual element. Adding a new label into the visual element. And also adding a new button, making it a child of the visual element. When we hover the cursor over the elements, it shows and highlights that area. And next I'm thinking to align these controls at center. Select the visual element and from the alignment tab select center. And also the justify content at center. Select the button and go to the text tab and resize the button. And now select the label and resize it as well. Changing the label to bank 0 and the button label to the coin clicker. They are very close to each other. Let's add some padding by going to the margin and padding tab. I have selected the label and adding a padding at the bottom. And that's how the UI looks like using the UI builder. Exiting the maximize mode and enter the play mode, and this is how the UI looks like in the play mode. We can click this button. At the moment nothing has happened because we need to link with the code. Create a new script to link with the label and a button, entering a script name as clicker, and open the script. To save your time, I have already written the code. Let's paste that code. We are using a namespace UI elements. Next we have three variables: label, button, and int. These will hold a label, a button, and a bank count. We will be attaching this script to the game object which have the UI element, and in enable we will get that UI document, and then we will access those controls, label and button. And line number 12, we are getting the UI document. Get component UI document dot root visual elements, and we are storing it in the root visual element. And then from the root visual elements we are accessing the label and a button. Here the queue is representing basically as a query. We have to find the label and we are passing the name of the label. This label name should match with the label which we have created using the UI builder. And here we are registering a callback for a clicker button, and we are calling a method increment bank. And the increment bank is a simple method that increment the bank count and update the label. And now on pressing the coin clicker, it will increment the bank count. So this was a very basic of UI builder and UI toolkit, opening a sample UI that are made with the UI builder. It's a sample UI for the tank sandbox. Here in the game window, and another UI, and here is one more sample. To try out the UI screens, you can drag and drop the files to the source asset. Let's focus on the custom inspector side. Creating a new folder, IM GUI test. Create a new C# script. Name it my player. Open the script. I have already written the base code. Get back to Unity and create a new game object. Name it as imgui_test. And attaching the script my player. And that's how the my player currently looks like. We need to create one more script. Create a new C# file and name it as my player editor. Open the script and replace the code that I have already written to save your time. We have created this my player editor to change the appearance of the script in the inspector. For the editor change, we are using a Unity editor namespace, and we are using a custom editor attribute for my player class, and we are using a can edit multiple objects attribute. It's not a mono behavior class, it's derived from the editor. And we have the serialized property for damage, armor, and gun. And in the enable class, we are finding the property of damage, armor, and gun and assigning it to damage prop. We have defined this damage, armor, gun in the my player class. And we are using our own inspector GUI to update the inspector UI and the values we will change. At line 26, we are updating the serialized properties, like when we will change the graphics or change the bar, it will update it. At line 29, we are using an editor GUI layout.inSlider and passing a few parameters like damage prop, 0 and 100. And that will be the range of the slider, and actual GUI content damage. Basically, damage will be displayed on the bar. You can say it's a title or label. 32 is just a safety check. And at line 35, we have the same thing for the armor. And at 38, again the safety check. At line 41, it's not a slider, it's just a field property. And at 44, we are applying the changes, basically re-updating it. And the progress bar method is to customize the layout of the progress bar. We are passing a value and a label. Using GUI layout utility.getReact, we are setting the margins. Line 52, we are updating it, and at line 53, we are just adding a little bit space. Get back to Unity. Give the editor some time to refresh and update it, and click on imgui_test. And here we have our updated UI. So we are achieving this result with a combination of my player script and my player editor script. So by this, we have extended the Unity editor and making our changes in it. I would like to mention here that the UI toolkit is also formally known as the UI element. Here we have a sample project provided by Unity. It's a very good game to understand more about the UI toolkit and Unity custom inspector. You should download this project and explore more. Here is a quick look how this project is managed in a Unity. And look how nicely they have utilized the inspector panel. And that was it for the custom windows and inspector. Look how nicely they have managed the assets for this project. These are very stunning animations and the assets are very optimized. I would recommend you should also learn the best practices from the existing projects. Take a look a bit at this level design and then we will be ending this video. From this level design, we can learn that we need to place only assets where the player have the viewpoint. So the developing the concept art is quite useful before developing the assets, and it gives you the overall idea how the final look and feel will be. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. In this video, we will learn how we can modify the enter play mode settings. When you enter the play mode, your project starts and runs as it would be in the build. Any changes you make in the editor during play mode reset when you exit the play mode. So each time that you enter the play mode in the editor, Unity performs two significant actions. The first is domain reload. Unity backup, unload and recreates the scripting states. And second is scene reload. Unity destroys the scenes and loads it again. And these two actions takes more and more time as your script and scenes become more complex. If you don't plan on making any more script changes, the enter play mode settings can save you a bit of compile time. Unity gives you the option to disable either domain reload, scene reload or the both. This can speed up entering and exiting the play mode. Now let's open the project settings. And go to editor. And scroll down till the very bottom. And these are the enter play mode settings. For the testing purpose, I am unchecking the reload scene and docking the window to reuse it. And now I am entering the play mode. And that's how much time it's taking to load. It's loaded. Exit the play mode. Open the project setting and now unchecking the reload domain too. Let's enter the play mode again and you see it's instantly loaded. Exit the play mode. Open the project setting again and check all the boxes of enter the play mode setting. And let's try again entering the play mode. And again it's taking some time to load. And now it's loaded. Just remember that if you do plan on making further script changes, you need to re-enable the domain reload. Likewise, if you modify the scene hierarchy, you should re-enable the scene reload. Otherwise, unexpected behavior could result. And here we have a chart that shows the effect of disabling the reload domain and reload scene settings. And that's it for the enter play mode settings. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. This video will further speed up the process of new script creation. Do you find that you make same changes every time you create a new script? Do you instinctively add a namespace or delete update events functions? Save yourself a few keystrokes and create a consistency across the team by setting up the scripts template for your preferred starting point. Every time you create a new script or shader, Unity uses templates stored at this location. This path is for Windows and this is for Mac. Let's open the folder at this location. As we are at the main desktop, open the Go menu and select Application. And you can also use a shortcut key Shift Command A. And here let's find the Unity folder. It's a Unity hub. We need a folder. Here we have a Unity folder. Open the hub folder, open editor, and these are the different versions we have installed. Select the version you are using with project, and I am using 2020.3. Right click on Unity and select Show Package Content. Open the Contents folder and select the Resource folder. And finally here we have the Script folder. And these are the files that Unity uses to create the initials. Extending the Finder to show you properly. The first file is used when we create a new script. Before modifying it, I will be taking a backup by copying it on the desktop in case if I need to replace it back. And the next step is open this file in a Visual Studio. So I guess now you recognize this is the file used by Unity when we create a new script. You see the namespaces and the start and update method. Creating a new folder to test the script templates. Naming this folder as script template. Before modifying the script template, let's see what we get when we create a new script. Created a default new script. Keep the default name and open the script. And this is what we get every time. Every time while creating a new script, I don't need this update method. And also removing the first two namespaces. And that's what I want to get when I create a new script. Open the script template and match with what you want to get. In the template script, we are removing these. And we don't need the update method as well. Clean up the extra space. And I would like to add a comment at the top. Modified template by Tanvir. Saving this template and switching back to Unity. If you want to create anything inside a specific folder, select the folder. I'm selecting a script template and creating a new script. We have new script behavior 1. Keep it the default name and open the script. Nice, now we have only what we need. So that's pretty clean and smooth, and definitely it saves me a few keystrokes to remove the extras. Although it's a small change, but in the long run it's really speed up the work, and not only for me, for everyone in my team. Let's try it one more time and create a new script. And it's incrementing properly. Now we have a script 2. Let's open it up, and it's working fine. It's a new behavior script 2. This way of modification will affect all your project. If I have a project A, B, and C, in every project we will get this script on creating a new script. And we can also modify it by only a specific project. For that, copy the complete script template folder and paste that folder inside the asset folder of your project. Here we have the script folder. Open the script folder and open the first script 81. I have already modified a bit by removing the comment from the start method. Save the template and switch back to Unity. Selecting script template to create a new script inside it. And creating a new C# script. And now we have a script number 4 that is further modified specific to our project. This way it's overriding the default template. Few important things to note: that relaunch your Unity editor every time you made a changes in a script template. So your changes should appear every time you create a custom mono behavior. And also modify the other templates in a similar fashion. Remember to keep a copy of your original and modifications somewhere outside the Unity project for the safekeeping. And for now, that was it for the script templates. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. The addressable asset system simplifies how you manage the assets that make up your game. Any asset including scenes, prefabs, text assets, and so on can be marked as addressables and are given a unique name. You can call these aliases from anywhere. Adding this extra level of abstraction between the game and its assets can streamline certain tasks, such as creating a separate downloadable content pack. This system makes referencing those asset packs easier as well, whether they are local or remote. Install the addressable package from the package manager. To work with addressables, we need this package. And these are the few dependencies that will be installed automatically. Click on install. And now we have the addressables. To open the addressables, go to Windows, Asset Management, Addressable, and select Groups. Click this button to create a new addressable settings. We can double click to maximize the window. And that's how the addressable window looks like, and we have a default local group as well. Dog this addressable window. Creating a new folder and naming it as Addressables. And other folder will be Prefabs. And from the scene, drag and drop the cube into the prefab folder to make it a prefab. Select the cube prefab, and here we have the option to make it an addressable. Check this option and soon it will be added in the default local group. Following the same way, I will be creating a prefab for cylinder sphere, and then we will make it a addressables. Creating the prefabs, selecting both and making them addressables. Unity will update the addressable window, and here we have in the list. In the list we have cube, sphere, and cylinder. Next, we will be creating a script to load them using addressables. Creating a new script example and open the script. To utilize the addressables, we need to add one more namespace, and that will be Unity engine.addressable assets. At line number 7, it will hold the asset reference. And using asset reference, we will call instantiate async to instantiate it. Now go back to Unity and removing these game objects. Creating a new empty game object example and assigning the script example. Jumping back to script. Making asset reference as public. Saving the script and go back to Unity. In the asset reference, select the addressable asset that you want to load. By clicking here, we see the list of all the addressable assets. I have selected a cube to load it. Enter the play mode. On entering the play mode, it should load the cube. And we are loading this cube using addressable local. The cube is loaded, our basic functionality and configuration is working with addressables. Testing it again, this time selecting the sphere. Testing a third one as well. And it's working fine. As these addressables has a very long address name, we can simplify them. Select all and right click and select simplify addressable names. It will take a bit and then it will update. Yeah, now we have the short address name. As we are talking about the addressable names, we can also change the name simply by modifying it here. Let's make it cylinder simple and hit enter. And it will update in the addressable groups as well. So you see we have the same name at both places. And now click on this build button and select new build and click on default build script. We are using the default build script to generate our addressable group asset bundle. We bundle these assets to be hosted on a server elsewhere or distributed them locally with your project. And the beauty of addressables is wherever each asset resides, the system will locate it and use the addressable name string. My platform is macOS, so it created a folder and a bundle inside it. We can also load the object by using directly their name. I am commenting asset reference line and add addressables dot instantiate async, and as a parameter pass the name of the object. We are passing cube. I want to load the cube. Go back to Unity and enter the play mode and it should load the cube. And our cube is loaded. Keeping the cube at the same time, we can also load the sphere. This loads the assets by its address string. The prefab does not load into memory until it's needed. In addition, Addressable provides high-level reference counting and automatically unloads bundles and their associated assets when they are no longer in the use. Addressables are very powerful and a good addition in Unity. And it's a very big topic to discuss. I have shown you the tip of the iceberg. So the conclusion is addressable takes a lot of manual labor and chance for error out for the packaging and handling of the assets are related resource. It separates the code and asset development paths and unifies the handling of remote and local content. It can even be used to allow for smaller initial download so that your player and user can get started quick and downloading the asset that won't need immediately while in the early stages. The utility of addressables is wide-ranging and rare in the project that you wouldn't benefit from it. And for now, that's it for the addressables. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. This video is about operating live games and cloud content delivery with addressables. If you are operating a live game, then you might want to consider using Unity Cloud Content Delivery (CCD) solution with addressables. Open your Unity dashboard and open the Explore Services tab. And under the All Solutions tab, you will see the amazing solutions provided by Unity. And the one we are interested in is in the Live Ops. Scroll down a bit and here we have a Cloud Content Delivery. Open it to view more detail. And on the left side, you find more options related to CCD. You can click the Start a Free Trial option and complete the process to access all these options. From here, you get the documentation for CCD and also API references documentation. You can read all these documentation and start the trial to begin your journey with the cloud content delivery and the addressables. It's a quite big topic to discuss and that was a quick starting point for the CCD and the addressables. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. This video is about Preprocessor Directives in Unity. The platform-dependent compilation feature allows you to partition your scripts to compile and execute code for specifically a targeted platform. Creating a new script. Name it as platform defines. And for the demonstration, I have this Unity sample code. This example makes a use of existing platform using hash define directives with the hash if compiler directive. And whenever we want to be a script run only to specific platform. For example, in the line number 7, we are using a hash if Unity editor and giving a debug log and hash and if. And that's how we define the code according to the platform. It will run only in the Unity editor. Next, we have Unity iOS. That means that will run only on the iOS device. My current platform of this project is macOS. That's why it's gray out. The next is for macOS and the last one is for the Windows. Switching back to Unity and we will see what will run. Create an empty game object and name it as platform test. And attach the platform defined script to it. Enter the play mode and open the console window. And we have the result as expected. It's printed Unity editor because we are in the Unity editor and macOS because we are in the macOS platform. Open the project settings so you see our target platform is at macOS. You can open the Unity documentation to see more directives. And that's it for the preprocessor directives. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. A scriptable object is a data container that saves large amount of data independent of class instances. And scriptable object can reduce your project memory usage by avoiding copies of values. I have this augmented reality currency scanner project, and this project have an implementation of scriptable objects. Opening the documentation of this project to see the project details to better understand the utilization of scriptable objects. And these are the major points in this project. At point number 5, it uses scriptable objects to create a data container that holds the image info and will be linked to Accelerator reference image library. Actually, let's have a demo of this project to better understand it, and then we will discuss how this project is utilizing the scriptable objects.
Canada, $20. China, 20 yuan. America, $20. Canada, $20.
Using this app, you will be able to detect banknotes, and on detection, it will speak out the banknote name. After developing this app, expanding is very easy. After completing this project, we can add multiple new country currencies without writing a single line of code. We will be just updating the image reference library and data containers with the new currency images. And now let's discuss how the scriptable object work. In the project, open the script folder and open currency scriptable object. A currency scriptable object class is inherited from scriptable object, and each of its instances contain currency value, currency name, currency type. So this data remains constant over the course of gameplay, making it specially suitable for storage inside a scriptable object. And this line number 4 create a menu, and we will click on it to create a data container. It will create a data container to store the currency information, and that file name will be currency data container. At line number 7, we are creating a list of currency data class. And at line number 10, we are defining a currency data class, and which have a currency and a binding. And in the binding, we have a country name and currency type. It will be more clear to you when you will see a data container in the Unity editor. In Unity, click on Assets, open Create, and here we have currency data container. It will create a new currency container data. Select it to view what we have in it in the inspector panel, and that's a list of currency data class that we have defined. Let's add one to add a new element, and here we have all the fields that we have defined in the script. So this container will help to hold the non-changeable values. In the currency value, we are adding a USA 500 when a user will detect a $500 banknote, and then some other script in this project will send a string to match with this string. Once the currency value is matched, that means we have the data of that note, and then that script will grab the data from the binding, country name, and the country type, and then utilize the information accordingly as we have seen in the demo, adding one more entry for the $100 bill. And that's how it's easy to extend the data. Similar to this, we can have a multiple data containers that can hold information of each country to make it a more simple. Like this data container is to hold the information of Canada. This data container is for China. We have a very less information in these data containers because it's just a simple demo, and we don't need to add these data containers in the scene view to any game object. The data is saved to scriptable object is written to the disk as an asset, so it can be persisted between sessions. And this is the currency image library. It's basically a XR reference image library. In this library, we have added all the banknote images to detect. In the currency value, we have given the same currency value in the data containers and in the image reference library. And whenever we match a banknote from this library, we send a request to a script which have all the data containers attached. You see this currency scanner script, it have all the country currencies, and we have a list of all the data containers. If that value matches from the data container, we grab the data and show to the user. And by using the scriptable object, it's very easy to extend this app. To add more currencies, we don't need to write any code. We just need to add a new data in currency image library and in the new data container. Further, I'm showing you the currency scanner script. But you don't need to really understand this completely. So I will just give you a quick high-level overview that is more relevant to the scriptable object side. Here we are using an AR foundation and AR subsystem. And the required component is AR Track Image Manager. It's used for detecting images in AR. We are getting AR Track Image Manager and assigning it to m_track image manager. In all country currency, we assign all the data containers. It's a list. All this part is for tracking in AR. And on track image change give us few events when it detects images, and we update few visuals accordingly. The update info is just for the experimental testing for now. It's not much optimized at the moment. It's getting the tracked image data and matching with the data containers, and also updating the few visuals on the screen. And this last method is for formatting strings. As a conclusion of this video, save memory and stay organized with scriptable objects. Set static data and settings in assets in the project just once, even if you have a lot of game objects. Even if you add 1,000th instance of a prefab to your scene, they still refer to the same data stored on your asset. Setting up the set of values just once guaranteed consistency. As your game scale up with the more unit types, simply create more scriptable object assets. And you can maintain your gameplay data just by tweaking the centrally stored assets. Scriptable objects don't replace keeping persistent data for rest of your application saves file, where the data may changes during gameplay. It's a workflow suited more for your sorting your static gameplay settings and values. Unlike parsing a data from JSON or XML, reading a scriptable object asset won't generate garbage, and it's a bonus, it's faster. Optimization tip for the scriptable object. I recommend binary serialization formats such as message pack or a protocol buffer for saved data, rather than the text-based one such as JSON or XML. In the project reviews, these binary serialization formats reduce the memory and performance issues. And you can read more about scriptable object from the Unity documentation. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. An assembly is a C# code library, a collection of types and resources that are built to work together and form a logical unit of functionality. By default, Unity compiles almost all of your game scripts into a predefined assembly. For example, assembly C#.dll file. This works for small projects, but it has some drawbacks. Number 1, every time you change a script, Unity recompile all other scripts. Number 2, any other script can access type defined in any other script. Number 3, all scripts are compiled for all platforms. Organizing your scripts into a custom assemblies promotes modularity and reusability. It prevents them from getting added to the default assemblies and automatically and limits which other scripts they can access. In this diagram, you can see the project split into multiple assemblies. You might split up your code into multiple assemblies as shown in the diagram above. Here, any changes to the code in the main cannot affect the code in the stuff. Similarly, because the library doesn't depend on any other assembly, you can more easily reuse the code in library in another project. Assemblies in .NET has general information about assemblies in C#. Refer to the assembly definition in Unity documentation for more information about defining your own assembly in the Unity. I will also be showing you how we can create assembly definition in Unity. Open the asset menu, go to create and select assembly. It will create assembly file. I will name it as my platform assembly. Open the inspector panel to view the assembly file. And these are the options available in this file. By selecting the platform, we can make it platform specific. In Unity, we can create assembly definition reference file by going to assets, create, and then select the assembly reference file. And it takes assembly definition file as a reference. Let's say I'm working on iOS, so I will select the iOS platform and hit apply. So in conclusion, assembly definitions and assembly references are the assets that you can create to organize your scripts into assemblies. And there is a lot you can do with assemblies. Please also refer to the Unity documentation for more details. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. Unity offers support for the following integration development environments. Number 1, Visual Studio. Number 2, Visual Studio Code. And number 3, JetBrains Rider. IDE integration for all three of these environments appear as packages in the Package Manager. Visual Studio is installed by default when you install Unity on Windows and Mac OS. If you want to use another IDE, simply browse for the editor, go to Unity Preference, External Tools, and select your external editor. Closing the preference window. Open the Package Manager to view the IDs of these packages. First, I'm looking for the JetBrains Rider editor. And you can install it if you haven't already. And this is Visual Studio Editor and Visual Studio Code Editor. My code editor required update, I will be updating it. Next, I will be opening a JetBrains Rider editor website to view the highlighted features. It's a cross-platform C# editor and it's very easy to start with Unity, and now we also have a built-in support in the editor. And it have a control Unity editor that give us a two-way communication. And it also includes the toolbar, game view buttons, play, pause and step, which correspond to the same buttons in the Unity editor and control the same. I personally have used all these three. And I love the code hinting in Rider most. It's better than the other two. The debugging is almost similar in all editors. And it's a plus point in the Rider, the performance highlights. It's really helping, especially for the beginners. And we also have find usage inside Unity files. Find usage now includes Unity scenes, assets and prefab. It's more like a quick search in Unity editor, but we are getting it right inside the Rider. It also gives us support for the shaders, syntax highlight and so on. If you need help for anything, you can get the link of the documentation. That's really helping. And this is the website of Visual Studio Code. It's a great companion to Unity for editing, debugging C# files, and all the C# features are supported, and plus colorization, bracket matching, IntelliSense, code length, and so on. All these three are very good with Unity and C#, but personally I find Rider more advanced. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. Debugger allows you to debug your C# code while the Unity entity is in the play mode. You can attach breakpoints within the code editor in order to inspect the state of your script code and its current variable at runtime. Open the preference window and go to General tab, and there you switch code optimization on startup from release to debug. The release mode disables C# debugging but improves C# performance. Switching to release mode will recompile and reload all the scripts. But now we have switched to debug mode. Close the preference window. Using this debug icon that is at bottom right corner, using it we can easily switch between release and debug mode. And it also gives you the tip regarding the switching mode. As we switch to any mode, the very last icon is start circling. It shows us it's recompiling and reloading all the scripts. And now quickly I have created a debug example game object and also attached a debug example script and wrote a basic script to test the debugging. It's a very basic script to swap two values. We have a value A and B. We will print the value A and B, then we will swap these values and then again we will print them. It's not a correct solution, but the point is we will debug it to make it right. Switch back to Unity and enter the play mode, and let's see what we have in the console. Opening the console window to view the debug values. In value A we have 5, value B 10, and after the swapping we have value A 10 and value B 10. But we will be expecting value B should be 5. Here our purpose is just to understand the debugging with the most basic example. Exiting the play mode. The first thing we are going to do while selecting the script game object, click on these 3 dots and select the debug. It will expose the private variable of our debug example script. So now we can see the value A and B. Let's enter the play mode again and keep an eye on the debug inspector on value A and B. As the code compiles, it replaces the both variable with the value 10. Next we are going to use breakpoints as it's not enough to identify the problem. In the code editor, set a breakpoint where you want the debugger to pause the execution. Simply click over the left margin area where you want to toggle a breakpoint. A red circle appears next to the line number of highlighted line. We added a breakpoint at our logic, as at this area the values are swapping. Switching back to Unity and enter the play mode. As the project will start, it will stop the execution at the breakpoint. It will take us directly to the dead line of code. The execution is stopped for investigation and we are in the Visual Studio. The first thing we can see the values by hovering over variables, and it's really nice to have this feature. At the bottom in the watch window, you can also add a specific values to track. One way is click on this plus sign and enter the variable name. And it shows us 3 columns, name, value and type. So the execution is at line number 13 and in the value A we have 5. Right click on any variable and select add to watch to add any variable to the watch. It's an alternate way of adding a variable to the watch window. At this point the value A is 5 because this line is not executed yet. Click step over to execute and go to next line. After the execution of line 13, value B is assigned to value A and now A and B is 10. So now we have identified the fault is at line number 14 as we were expecting to assign 5 to the value B. But we are assigning a 10 to the value B that is already the value of B. So what we need to do is to hold the value of A temporarily before assigning the value of B to the A. At the first line, assign value A to the temp value. Assign the variable value B to the variable value A. This time before replacing the value of A, we are holding the value in the temp value. Next, assign the temp value to the value B. The temp value is actually a value of A. So basically we are assigning the value A to the value B. Keeping the breakpoint at line number 14, it's the first line of our logic. Back to Unity and enter the play mode. Step over to next line. Hover the cursor over the temp value to see the value of the temp value. We stored A in the temp value. Step over to next line. Value A is replaced with 10. Step over and next we will be replacing value B with 5. So now we successfully replaced the values of the both variables. You can stop the debugging using this stop button. You can remove the breakpoint by right clicking on it and select remove breakpoint. Switch back to Unity and enter the play mode. This time it won't stop the execution. Open the console window to view the debug values. And here we can see the expected swap values. Using Visual Studio, you can directly enter the play mode. Select your breakpoint and click here to open the list and select Attach to Unity and Play. This way you don't have to switch to Unity every time to enter the play mode. You can directly play it from the Visual Studio by clicking Add here. It will enter the play mode and stop the execution as we are expecting. And as usual, we can use the step over to execute and go to next line. Next is searching. We can search a specific variable in the script by going to a search menu and click find. It will highlight this variable at all the points and we can use these arrow buttons to navigate them. You can also quickly replace the specific variable by going to search and replace. And here you can add the variable you want to replace. I'm typing value AA. And press the replace button. I'm pressing Ctrl Z to undo this replace action. Open the search menu and click on Find in Files. Using this option, you can find the specific variable from the whole solution, or you can select the other options from this look-in list. Let's try the whole solution first. That was the default. Click on Find. It's searching the whole solution and it's giving us where the value A is used. In this project, we are only using in the debug example. Click on these three dots and select Open Editor Log. You can use this debug window to view the logs of the Unity editor. Enter the play mode and the logs will popping up in this window. These logs are especially helpful when your game is freezing or it's crashing. Mostly we are using debug.log, but we also have a debug.log warning and .log error. Log warning is used for warning messages and log error for the error message related. Enter the play mode and open the console window to view these messages. And by pressing these buttons, you can filter the different type of logs. By pressing this log button, it will hide all the logs and it will hide all the warnings and all the errors. And that's how you can filter the different logs. Next we have debug.drawArray. To demonstrate it, I have quickly set up the scene. Created a bunch of cubes and attached them example class script. And these cubes will be raycasting to detect anything. Open the script and that's our basic raycast script. At line number 10, we are casting the ray in the forward direction. And if it will hit something, it will print did hit. Switch back to Unity, enter the play mode and open the scene window. As we can in the scene window, we have no visuals regarding the raycast. This way it's very hard to know what's going on with the raycast. We have the option to add the visuals for debugging the raycast. Going back to script and adding debug.drawArray. In the drawArray, we are passing the position, direction and a color. The line will have a yellow color when it will hit something and the white color when it hit nothing. Going back to Unity, keep in mind these lines only shows in the scene view. And these lines are showing us the raycasting of the cubes in a forward direction. The cubes with the white lines are not hitting anything. And the cube with the yellow line are hitting on something. These draw lines are updating real time. You can move around the cubes to view their action. And of course, we can also change their rotation as well. It's a basic example, but in a very complex game, it is very helpful. If you are facing issue in your project, it's almost impossible to understand the bug without these things. Every developer should have a strong grip on the debugging. If you only want code to run when development build is enabled, you can check if debug.isDebugBuild returns true. As in summarizing this video and the other tips, Unity includes a debug class to help you visualize information in editor while it is running. Use it to print messages or warnings into the console window. Draw visualization lines in the scene view and game view, and pause play mode in the editor from the script. You can pause the execution with debug.break. This is useful if you want to check certain values in the inspector when the application is difficult to pause manually. You should be familiar with the debug.log, log warning, and log errors for printing console messages. Also handy is debug.asserts, which asserts a condition and logs on error on failure. Only works if Unity assertion symbol is defined. Next is when using a debug.log, you can pass an object as a context. If you click on the message in the console, Unity highlights the game object in a hierarchy window. Next is you can use rich text to mark up your debug.log statements. This can help you enhance the error reports in the console. And the next tip is Unity does not strip the debug logging API from the non-development builds automatically. Wrap your debug log calls in custom methods and decorate them with the conditional attribute. And removing the corresponding scripting defined symbols from the player settings compiles out all the debug logs at all once. This is kind of identical to wrapping them in a hash if and preprocessor blocks. And next is regarding the troubleshooting physics. Debug.drawLine and debug.drawRay can help you visualize the ray casting. And the last tip is use application.setStackTraceLogType or the equivalent checkboxes in the player settings to decide which kind of log messages should include in the stack trace. Stack traces can be useful, but they are slow and generate garbage. You should have a strong debugging skills to have the maximum performance of your project. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. If you have choose Visual Studio for the development, it's a great editor to work with. It have ton of options to speed up our work process, and even we can add multiple predefined methods with just a click. You can search and open a specific script by searching here. I want to search and open debug example. Hit enter or select the script. Press Command-Shift-M or Control-Shift-M on Windows to open a window Unity event functions. Check the fixed update method and select the insertion point and click on add. It will add the selected method in your script. Simple is that. Placing my cursor at line number 8 to add the next method at this point. Let's open the window again, Command-Shift-M, and adding the wake method at here. This time I will be adding a method after the fixed update. Open the window and select the method. I'm selecting a late update. Also check the generate method comments. Insertion point is after fixed update and click on add. This way it will add the method after the fixed update, and this time it also added a comment as we have selected that option. We can also search for a specific method. Let's search for the onEnable, and we can add even multiple methods at once. Now let's search for the onDisable and select it. Let's also search and select onDestroy, and this time our insertion point will be after the update method. Also checking generate method comments, and here we have the information what we are going to add. In Visual Studio, it's a very nice way of adding a predefined methods. To comment out the line of code, select the line of code and press shortcut key Command/. You can press Command/ from anywhere on the line. You don't have to be at the start. You can even select a multiple lines, a block of code to comment out using the same Command/. And to uncomment the line of code, simply press the same Command/. And the same way select the block of code and press Command/ to uncomment all code. And the next is rename a variable while updating all the references. Select the variable and press Command-R and update the variable. It will update all the variable references. And now everywhere we have value 1 instead of value A. Let's try this again with the value B. Press Command-R and this time we will change it to value 2. And that's how it's simple in the Visual Studio to change a variable name in the complete script. In case you was making a prototype and you never focus on the naming, that's how you can update all the naming to a proper naming. Next we have increase or decrease the font size. You can use the shortcut key command minus to decrease the font size and command plus to increase the font size. To view all the Visual Studio commands, open Visual Studio, select Preferences and go to Key Bindings. And these are almost all the commands used in the Visual Studio. Description is also written in front of the commands. You can learn all the commands from here. I will be scrolling a bit to show you these commands. And next we have how you can change the code color theme. In the preference window, open the color theme tab. This is the first thing I change whenever I install the Visual Studio the first time. And these are the different themes are available in Visual Studio. You can choose any theme according to your liking. I will be switching back to dark theme and close the window. And the last we have to format the code. Select the block of code and press Shift Tab to make the code on the left and press Tab to make the code on the right side. And further we have these list of commands and we have demonstrated few of them in this video. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. If you are developing for a mobile, the device simulator, currently a preview package, can help you simulate your application on different devices. Even if you have physical access to all your targeted hardware, building the content for each device can be time consuming. Open the package manager and search for device simulator. It's not displaying because it's in a preview version. Enable the preview package option. From the project setting, click on this Enable Preview Packages and click I understand. Close the window and search for Device Simulator. Here it is, install the package. Close the package manager. You can find the Device Simulator window from Window menu and go to General tab. And at the very bottom, Device Simulator. So this was the one way of accessing the Simulator tab from the menus. Let's close this window. We can also open a simulator from the game window. Click here and select Simulator. Adjusting a window space for the simulator. From here you can open the available list of simulators. And we have simulator for different vendors. It's a Google Pixel 2. You can also search a specific model. I will be searching for iPhone XS and select the device. For this video, we will also compare this simulator with the actual device to see how closely this simulator works. And we can open different scenes to view the result on this device. Using these rotate button, we can rotate the simulator or this device. And this button to fit on the screen. And the scale slider to change the scale. And now these days different devices has these notches. Using this safe area, we can view the safe area on the device. So we can adjust the UI according to the device. Enter the play mode and interact with the different UI options. With the default UI setting, it's kind of difficult with this notch device, as some part of the UI is overlapping with the notch. Here I have adjusted the UI according to the safe area. Now I can easily interact with all the UI parts. And the notch is not disturbing anymore. Next, we are comparing the Unity simulator result with the actual device to see how much accurate it is and how much we can trust on it. For this demonstration on the Unity editor, we have selected iPhone XS as a simulator, and this is the same physical device iPhone XS. And we can see the results are exactly the same. Also try the portrait mode. That's really save a lot of time and speed up the process of testing. The device simulator also approximates the hardware performance. Adjust quality settings based on the RAM, chipset and other hardware specs, and your game code will simulate playback on the platform accordingly. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. Is for the more readability on the console panel. By default, the console log entry shows 2 lines. For improved readability, you can configure this to be more streamlined with 1 line. Enter the play mode and we have different logs here in the console panel. Click on this 3 dot button and from the log entry, select 1 line. It makes all the logs to take only 1 line. If you have too many logs, you can make it 1 line to have more readability. And the same way you can make it 3 line. This way it will give you more data per log, as 1 log will be using 3 lines. And the same way we can make it 5 lines. If you want more data from 1 log, you can increase the line. And that's a way of changing logs, and you can change according to your project need. From here you can select different log clear options, and from here you can collapse similar logs. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. In this video, we will be creating a custom floating window for the compiler status, as the existing compiling icon is very hard to see. Using the editor script, we will be creating this window. I have already created this script to demonstrate you. I have named this script custom compile window. We are using this custom script to call editor application.isCompiling. We are using a namespace Unity editor and inheriting from editor window, and adding an entry in the menu using menu item example / custom compile window. In the init method, we are getting the window and calling window.show. And in the on GUI, we are checking for editor application.isCompiling, and accordingly we are displaying it using this .repaint. Switching back to Unity. The last icon in the corner shows the progress detail or the compiling status. We have created the alternate of this. Open example and select custom compile window. And this is the floating window we have created using the script. And I am going to dock it at the bottom right corner, so we can also verify the status with that icon. Now let's try making some changes in the script. So when we will save it and come in the Unity will recompile it. And our new custom window will print yes if it's in the compiling mode. Switching back to Unity, and it's compiling and we have the status of yes. Once the compiling will finish, it will print no, and the corner circle icon will back to its default icon. And that was a small tweak in the editor. I hope this video helps you. If you have any questions, you can always ask me. Thank you for watching and I see you in the next. Every development team needs a good way to manage changes and version code in their code base. That's why they use source control tools. We also call it source control management or the SCM. Open the edit menu, open the project setting, and in the last version control tab. Unity has integration with two version control systems, Perforce and Plastic SCM. You can select any server and enter the credentials, and you can get the credentials from their website. Or you can also use external systems such as Git, including the Git LFS, that is for large file support, for more efficient version control of your larger assets like graphics and sound resources. Install the source tree. It's a free Git client for Windows and Mac. It's a visual client for managing your source code. To demonstrate in this video, I will be using a Bitbucket instead of a GitHub. Scrolling down the source tree page to show you some information. To work on Bitbucket, you need to create your account, and for individual use, creating account is free. Scrolling the Bitbucket page to show you some information. On your system, open the source tree client. And this is the list of working project. To add a new account, open source tree. Click on Preference and go to Accounts tab and press Add to enter the credentials. From the first host tab, you can select which hosting service you are using. In my case, I am using a Bitbucket, but you have several other options to use. Next, you need to select the authentication type. In my case, I am selecting a basic. Here you type the username and password that you get from the Bitbucket. Select the prototype as HTTPS, and that's it. Now press save. Closing this window, and by clicking the new button you get these options. I have selected the clone from URL if you want to clone a repository from the URL. You can also create a remote repository. That means it will be linked with your account and will be saved on the Bitbucket server. Enter the name, it's basically your project name. Enter the description and the project type, keep it as Git. This is a private repository is checked. That means it will be a private repository. It's your personal project and only you can access it. We can also create a local repository that will stay on your system, on your local system. And you can scan the directory for the existing project, and then we can also push them to remote. And in the remote section, it shows all the projects that we have on the Bitbucket server. And we can click on this clone button to clone it on our system. And then we make changes on it, and source tree detects those changes, and with the help of source tree we commit those changes back to the Bitbucket server. And that's how this process works to manage the code. I'm opening a current working project, and that's how the project dashboard looks like. At this branches section we have all the branches we are working on. We can double click on it to open the branch. And this is a commit button to commit the changes to the server. In this section, it shows all the affected changes. From this checkbox, we select all the changes. Here we add the description what we have done in this commit. Or we can push these changes to a new branch. Here we can enter the name of the branch. Let's say I want to make all the changes in a video folder. I will type video / and enter the name of the branch. I will name it as Video 6 Teamwork. It's better to type in small caps and use a dash to separate the words. Press the create button to create a new branch. Now you can see the Video 6 Teamwork in the branches section. and it's in the videos folder. But currently we have this branch at local machine, we need to push it. Click on the commit button. It's asking because we haven't given a description. It's always good practice to add a description. Press OK. Press OK. Now it's uploading our code on the Bitbucket. The code is committed successfully. For the source control management, if you are working with the team, it's better every developer should have their own folder. It's better the folder should be with the developer name. I'm using, for example, a developer1. After the slash, the commit name. And press create branch. Take a look on the branches side. Now we have a new folder with the developer1. And every developer should repeat this process with their own name. Let's create one more developer with the name developer2. It's a very useful process if you have a big project with the multiple members in your team. Quickly adding one more commit in the developer1. That's how it looks. This section shows all the remote branches. To view the current branch on the remote on the web, click on this View Remote button. It will open the Bitbucket website or your server you have configured. This is how your project looks like on the web server. Switching back to Unity. Next, I will be making a few changes in the scene to show you the process how the source tree detects changes, and then we commit those changes on the server. Switch back to source tree, and source tree detected uncommitted changes. Click on it. In the uncommitted changes, we have custom menu.unity. At the commit button, it shows we have one change to commit. Enter the commit message, creating a new branch under developer1. Press commit, and that was a complete way of updating the changes. And one of the very important part in the source control management is the .gitignore file. In the Finder, open your project folder. On the Mac OS, use shortcut key Command-Shift- to reveal the hidden files. Open this .gitignore file. It's a plain text file. In this file, we have the path of directory or the files that basically we want to ignore. We don't want to commit these files. These can be a temporary files generated by Unity, library folder or the temporary folder, maybe the builds with the .apk or the Unity packages. And this file is stored at the root of your project. These are the other helping tools for the source control management. I would suggest go to their websites and read more about them. It's a Git LFS website. Second, we have a Git for Unity. Install the GitHub for Unity plugin. This open source extension allows you to view your project history, experiment in branches, commit your changes, and push your code to the GitHub without leaving the Unity. As in the video I shown you previously, Unity maintains a .gitignore file. This can help you decide what should and what shouldn't go into the Git repository and enforce those rules. Open the Unity Asset Store on the web and add GitHub for Unity into your account. Open the package manager in Unity and go to My Asset section. There you will find a GitHub for Unity and download it and then import in the project. And you can open the GitHub from the Windows menu and click on GitHub and add the required credentials. Unity Teams is another option for streamlining your teamwork. Unity Teams allows you to store your entire project in the cloud, so it's backed up by accessible anywhere. This makes it simple to save, share, sync your Unity project with anyone. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching and I see you in the next. The Unity Accelerator removes waiting time by caching copies of your team's assets. This means that only one person needs to perform the actual import, and the result will automatically be cached to the Unity Accelerator. The next time team goes to import the same version of asset, the Unity editor first checks the cache before starting the import process on their local machine. In Unity 2020 LTS, you now have a local administrator dashboard. For the accelerator, that enables you to configure the tool, see the statistics like disk space usage or how much time you have saved, and the diagnose issues with the logs. Optionally, the accelerator can be used with the Unity teams, advanced to share collaborate source assets, which significantly reduce the download time from the collaborate service. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. Consider enhancing your team productivity by offloading the building process to network hardware using Unity Build Server. This will help your creative team build the project as often as needed, allowing them to iterate more automatically. As your Unity project grows in size and complexity, generating a build consumes more and more time. If you are using your development workstation to build your project, you will lose productivity while your team waits for the build to complete. Unity Build Server runs Unity in batch mode, exclusive for building Unity projects. Team members can request builds on demand at their own pace. This reduces the wait time for bug fixes and releasing new features for the testing. Building on separate machines reduces each developer downtime and allows everyone to iterate more quickly. Both Unity Pro and Unity Enterprise subscriber can get access to Unity Build Server. Unity Pro customer can get add-ons packs, while Unity Enterprise customers receive a number of build server licenses based on their existing enterprise license. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next. In this video, we are going to cover several tips and tricks for Unity, and they will be speeding up your work process, and overall it will save you a ton of time. The first one is how we can view the background running task quickly. When the Unity have running background task, the progress bar shows here, and it also shows the name of the job that is running, and you can click this bar to know the more detail. There you will find the number of jobs and how much time it will take to complete, and the percentage to complete. Alternatively, you can also hover over the progress bar to know more about detail. Now the running task is completed. Normally when we create a material, the process is first we create a material. Press the material. And after the material is created, then we select the shader and assign the required shader. But we can also select the shader and right click on it and select create material. This way we don't need to apply the shader separately. It will create the material using that shader. Next we have global and local. Selecting the rotating tool and rotating this parent game object, and we are set at pivot. In this parent object further we have two childs, and we are rotating them using the global. And now change pivot to center. Using center we have the average or the middle point of the game object, and in the pivot we have the actual reference point. When we are moving a game object globally, that's mean we are moving it according to the scene coordinates. Every scene in the Unity comes with its own coordinate system. That's basically is called global. Regardless of the actual direction of the object, we are moving it globally. But as we turn on the local, you see the handles are changed according to that specific game object, because now we are in the coordinate system of that particular object, and in Unity we call it local. Changing back to global, now you see the difference. Let's try this on other game object. And that's it for it. I think it's a pretty straightforward explanation for local, global, center and pivot. Next we have a shortcut key to maximize any window. Move your cursor on the window and press Shift Space. Again press the Shift Space to exit the maximize mode. This time I move the cursor to the scene view and press the command. And that's a very quick way to explore something on that particular window. And in a split of a second, it's give you the maximum space of your screen. Pressing the same command again to exit the mode. Now let's try this on a game window. Using Shift Space, we can even maximize the inspector window. And same command to exit the maximize mode. Let's try this on a project window. On a massive project, it's going to be very helpful. You see it's working on every window. And next is also very interesting. Select any game object. Select this 3-dot button and select Expand All Component. It will expand all the components attached to this game object. And the same way, you can collapse all the components. You see, it's a very quick way of doing it. Press this Edit Collider button and now you can edit the collider in a customized way using these points. And next we have is to focus on any selected game object. Select the game object and press the F key. In a bigger game level, we can quickly move to our desired game object. If we use mouse and keyboard and navigate to that game object, it's gonna be a time taking, and this shortcut key is very helping. The next is Align with View. In a scene view, you finalize your camera angle and press Shift Command F to match the view with your camera angle. When we are aligning with view or using this shortcut key, we are matching with the main camera. Go to Game Object and select Toggle Active State. It will disable the selected game object. You can also use a shortcut key to disable any selected game object. And the shortcut key is Command Shift A. But to enable it again, you have to select it from the hierarchy view. This button is used to show and hide the gizmos. And we can also turn on and off the 3D icons. And we can enable the third option, Selection Wire. The selection wire is an important feature. We can see the model in a depth to identify is this model in a low poly or in a very high poly. At least we get the basic idea of the mesh details. And this knob is used to change the size of the icons. This button is used to toggle the grid visibility, to turn on and off the lightings. And this is to switch to 2D mode. And from this list we can switch to different type of modes. This is wireframe mode. And next is copying and pasting a component. While we are in a play mode, we can edit and copy the component. I'm copying a complete transform component, exiting the play mode, and now pasting the transform component. Paste component values. And now we have the same object that we left in the play mode. I'm typing 4, and to complete it I'm pressing double tab, and this time I'm selecting a for each loop, and to complete the loop you can press tab 2 times. I hope this video helps you. If you have any question you can always ask me. Thank you for watching and I see you in the next. You can find additional productivity tips, best practices and news on the Unity website and Unity blogs and on Unity community forums and on the Unity Learn. The Unity Developer Tools microsite makes it easy for you to find some of the best resources for developing with Unity. That includes documentation, the knowledge base, issue tracker, and Unity latest roadmap and release information. Thank you for joining and completing this course. I will be keep updating this course and adding more new videos. And you can also ask me any topic you want. I will be making video on that and will be added on this course. And again, thank you so much for joining this course and keep learning and take yourself. I hope this course helps you and I will see you in my next course.